Be very participative. Come on video and keep it as a practice. Not only here in the Six Sigma training. Any training you join, you have to derive the benefits out of it. So make it a habit, and definitely that will pay you back. Yeah.
Good morning, all.
So very good morning. So tell me, when did you perform, or when should you perform an hypothesis testing? Come on, Ravi Chandran, Chandru,
Yes,
Ravi
sir. So
Kiran.
whenever we have issues, whether we need to validate whether it is right or wrong, so that time we have used the hypothesis system. In that
Slight
time,
change, slight change. Whenever we have a claim,
yes, we have.
issue we did understood and define itself. Now it is claim,
Yes.
right? Continue.
And we have a two type of hypothesis. Suppose we have to check. One is the alternative hypothesis. One is null hypothesis. So normally, alternative hypothesis is a progressive point of view, and null hypothesis is no impact.
Very good,
And
very good, very good. Mm.
And in the average of hypothesis, we have there are several, six type of tests is there. One is the Z test, and T test, and chi-square test, and ANOVA test. So in the Z test, we have to measure. There are two kind of one sample Z test and pseudo test. Normally, Z
Mhm.
test can be used in proportion
Proportion test is also a type of G test
Z
only.
test.
That is the
Yes.
point there, right? But
Yeah,
we
and
have a separate name, proportion test. But there also the G score is used. That is the only point. You don't have to confuse, no, jet and proportion. Mm.
the
Okay,
mean.
so
Yes, sir.
yes, so I want to highlight few things. Hypothesis testing is required whenever you are in doubt. If things are very, very clear, please go ahead. Please go ahead, isn't it? You unnecessarily don't have to waste your time, effort, or resource. But if you are in doubt, you have a doubt about certain X factors, maybe temperature, maybe pressure, maybe concentration, or maybe the employee skill, or maybe you doubt, whether the gender of the operator can influence your quality. Whatever it is, their marital status, you doubt whether their marital status can be a factor or not. You study everything, all of that, and come to a proper conclusion. And again, this conclusion is statistics based. It depends on several factors, the kind of statistics you used, or the kind of hypothesis test you use, and the quality of data you use, right? And all of this depends, and the amount of data you use. So there will be some limitation, which is known as the uncertainty in your decision. No decision can, we can make without error. But like RK was giving an example, yes, you can make certain claims with zero error, but such claims will not be useful, like expecting the mark between 0 and 100. So this is of no use. Everybody knows. But the challenge is we want to make predictions in a lesser interval. That interval is known as our confidence interval. That interval is known as our confidence interval. Just to understand or connect our learning on hypothesis testing, let us take a case of Virat Kohli's one-day international performance. What is the batting average of Virat Kohli?
58.
58. And suppose if India has to play another series of 10 or 5 or 10 matches, what could be the batting average of Virat Kohli in the upcoming series?
It will be average 58.
It could be same 58.
Uh, it will be vary, but the average will be maximum 58 only.
Yeah, it will definitely be around 58, because so far the performance says the batting average is 58, and so you can definitely expect his batting average in the next series also to be around 58. All of you agree with me? Where from you get this knowledge? Normal distribution,
Yeah.
right? Your data will cluster around the center. Normal distribution also tells something else. The distribution will be symmetrical at the center, which means Virat Kohli can score above 58 also, can maintain an average of above 58 also,
And below
can
also.
maintain below also. How much is the probability for maintaining average above 58?
Above and below both.
What is the probability? Probability means percentage. How much chance is there for Virat Kohli to maintain a batting
100%.
average?
100% also. 100%.
You have not understood normal distribution. 50-50.
50.
Imagine you are producing a product with with the targeting 100 mm dimension. You produce this 1 million parts. Do you think all 1 million parts will be above 100 mm?
No.
Half of them, approximately half of them
Okay.
will be above 100 mm. Approximately half of them will be below 100 mm. So what is the probability for you to produce parts above the targeted value or above the average? 50%.
50%.
Probability for your process producing parts below the average value, that is also 50%.
50%.
This is what we call it as p-value. Something happens. What is the probability for such an event to happen? Similar event. You observed 100 mm. Now you need to ask yourself a question. What is the probability to achieve 100 mm or above it? What is the probability for you to achieve 100 mm or above? This is the definition of p-value. Yesterday you talked about p-value? Yes or no? All right. So 50 plus or minus is going to be the average. That amount of plus or minus depends on the confidence interval you want. I want always the general practice is 95% confidence interval. Tell me, with the 95% confidence interval, what will be the range of batting average for Virat Kohli in the next series? Make a guess. Don't worry about, you don't have data right in your hand, but still make a guess. Can I say 58 plus or minus 5, plus or minus 5?
Yeah.
Now how much is 58 plus 5?
63.
63. And 58 minus 5?
53.
53. The 63 is known as your upper confidence limit. And 53 is known as lower confidence limit. Don't confuse this idea with control limits. Symbol, no, the denotion is same, UCL, upper confidence limit now. 53 is lower confidence limit. You already studied something about control limit. Can one of you tell me what is control limit? What is control limit? Control limit is a point which is 3 standard deviation away from the center. You remember or not? We spoke yesterday. RK was showing the car, isn't it? Car example. Isn't it? Do you remember, all of you?
Yes, sir. Yes, sir.
So what is the definition for control limit? Point which is away from the center by a distance of how many standard deviation?
3.
3 standard deviation. That is why you call 6 sigma. The spread of the process is 6 sigma, isn't it? Any process can stretch up to control limit. Upper control limit on the right side, lower control limit on the left side. So the distance between UCL and LCL will be 6 sigma. I am asking you what is the definition for UCL now? 3 standard deviation away from the center on the right side. Now one of you tell me what is the definition for lower control limit? Again 3 standard deviation away from the center, but on the left side. So now you are clear about upper control limit and lower control limit. Now I am talking about upper confidence limit and lower confidence limit. Upper confidence limit and lower confidence limit. And what is the percentage I am using? 95% confidence limit. When I say control limit, my confidence is 99.73. Make it a point. When I say control limit, it is 99.73. I don't want 99.73% confidence limit because that's not a common practice. The common practice is 95% confidence limit. So upper confidence limit is 63, lower confidence limit is 53. All of you are clear so far? All of you are clear? May I have all of you on video, preferably, always in the discussion mode. Most of you, whoever, are ready, please be on video. Let's be very lively. Okay. So upper confidence limit, lower confidence limit. Now, the Indian team want to experiment something. They know Virat Kohli is the backbone for the Indian team. They wanted to boost Virat Kohli's average further. So they appoint a special coach for him. The coach has come from South Africa. And the coach is giving Virat Kohli an extensive coaching. He teach him new techniques, all of this, right? And for 3 months it happens. And now Virat Kohli is more energetic. He feels, the company of the coach. And now he is playing another series. And the salary for the coach, it is running in $1 million. So, so the team is also desperate of seeing the result. Right? 3 months of coaching, whether the average is going to leverage or not. So Virat Kohli actually plays the series. So many matches he plays, and this time they calculate the batting average, and the batting average is found to be 59. Now, what is your conclusion now? Have you spent the money productively, or have you, do you think the improvement? How much is the improvement? His normal batting average is 58, right? But now what is the new batting average?
59.
59.
59. You have done an experiment. You spent 3 months of time. Only played about 10 matches. And now the new average is 59. The population average is 58. But there is an improvement. But you are paying the coach in crores. Can you give this credit of 1% improvement to the coach?
No, sir.
Is it because of the coach? 1% improvement? Is it because of the new techniques Virat Kohli learned?
No, sir.
Or it has happened just like that?
No,
This choice of
It should have happened just like that also.
New technique, yes.
This doubt
it's me. I'm not.
is more. This doubt is more now for you. Even though you have a coach, even though there is an improvement, still you're not willing to give the credit to the coach simply because your doubt on the event happening on its own is high. You understand? When we talk low, high, very subjectively, qualitatively, no, it becomes difficult for decision making. So we bring some guideline. Whenever the doubt or the uncertainty is more than 5%, we will not give the credit to the coach. Whenever the doubt is more than 5%, we will not give the credit to the coach. But when that doubt is less than 5%, because 100% exactly prediction is difficult, people know. So 5% doubt is okay for me. But when I say 59, the doubt is very high. We can even pinpointedly calculate that probability of our prediction going wrong. We can do that. And the purpose of the tool p-value is exactly that. So p-value is the probability of random chance creating the data in your experiment.
Wait.
P-value is the probability of random chance creating the event or creating the data. What is random chance creating the data? Your statistics is not influenced by the factor you are studying, but by something else. Am I correct? The difference in the statistics you observed in your experiment is not due to the factor you are studying, can be due to something else. This is what we call it random chance generating the data. And you will think that it is because of coach, but actually which has generated it? Tell me.
Hey,
Random chance.
take this.
Imagine you are writing the green belt exam. There are questions, 50 questions, all MCQ. You are choosing one out of the 4 options without reading the question.
Randomly, that is.
You are not reading the question. You are only choosing the answer. First question, option A. Second question, option B. You are not at all reading the question, but you submit the exam. You are happy to see a pass mark. It should happen, but we have made it, a rare event. So don't try on that, isn't it? The chances are very minimal. Can you see that? But I cannot say no, there is no chance. Somebody might even pass. But we designed our process in a way that the chances are minimal. And how you pass the exam now? By random chance. Am I right or not? We think that the pass mark is because of the efforts you're putting in the course. But actually what happened is it happened because of something else, not the factor. How much chance is there in your experiment for such thing to happen? The permissible risk allowed is, or the permissible risk allowed is, chance allowed is 5%. This is what we defined as level of significance. How many of you noticed it yesterday? We defined it as level of significance. Level of significance is how much? 5%. 5% of risk risk in your decision is okay for us. All of you are with me so far? 5% of risk okay means you should be confident at least 95%. Clear? Your
Clear.
confidence level must be 95%. Now going back to Virat Kohli's same case. Earlier, the batting average pushed from 58 to 59. Why are you not able to give the credit to the coach? Because you know that the batting average can move anywhere between 53 to 63 on its own randomly. Yes or no?
Yes, yes.
Yes.
Whether I appoint a coach or not, Virat Kohli's batting average always moves between 53 to 63. That is what I noticed in 95% of the cases. I call it 95% confidence limit. Imagine another coach. Earlier, we have appointed coach from which country? South Africa.
రెండు చేస్తాను
Now you want to try with another coach.
ఒకటే
This
కదా
time the coach comes from New Zealand.
అన్నం పరవాన చేయనా
This time the coach comes from New Zealand. Similar experiment is done. 3 months, intensive coaching, etc., etc. Another series. Now another series, Virat Kohli has batted well and his average is found to be, 72. What is his batting average?
72.
And now, will you be able to happily give the credit to the New Zealand coach?
Sure, sir.
yes yes
Yes, yes.
Just more than 5%.
Why? What's the difference you noted now? Earlier, there was an improvement of 1%, but this time there is an improvement of, how much I said? 72, right? So 9%.
9%.
Earlier, earlier also there were improvement. Now there is an improvement. Earlier it is a random improvement, but now it is a significant improvement. Can you see that? Now we are able to use the English word significant.
Significant.
That means the addition of coach is a significant factor. Virat Kohli, team must consider keeping the New Zealand coach for Virat Kohli. They can continue. That will definitely, be helpful. Please note, what is the statistics we used in this case? Average, right? Batting average. Whenever you notice your statistics inside the confidence limits, we don't consider that as significant. Clear, all of you? Now I am giving you the
Yes.
rule. Whenever you see your statistics inside the confidence limit, we don't call it significant. But whenever we see the statistics, going outside the confidence limit, from beyond 63, any observation beyond 63, we will consider as significant. This is what you are doing in hypothesis testing. Clear, all of you?
Sir, what if it is less than 53, sir?
Less than?
53,
Less than
sir.
53. Less than 53 also significant, which means the effect is negative. You should immediately remove the coach. Above 63, you must consider retaining him. 53 to 63, no decision can be taken because the risk associated with your decision is more than 5%. Whenever the risk associated in your decision is more than 5%, it is better not to decide. That is the rule of the game. That is the rule of the hypothesis testing. This is what we call it type 1 error. Whenever the risk is more than 5%, the risk of rejecting a true null hypothesis. The risk of rejecting true null hypothesis should be less than 5%. See here, I have come to Minitab screen now just to show you the illustration. I'm going to graph. I'm going to probability distribution plot. I am choosing view probability. I want you to choose normal distribution. What is the batting average of Virat Kohli? You said 58. The mean is 58. And now his standard deviation. What is the upper confidence limit you told me?
5
53.
Five. Standard deviation 5.
Yeah, I'll come to that. I'll come to that. Okay. So approximately, I'm just putting some value here. So let me say just 1.5. I'm putting 1.5. But actually, we need to put standard error here. We will talk about standard error a little later. But I'm just putting some value here. Now, shaded area. And now let me find out the 95% probability. I want the 95% probability area in this manner. The area between, okay, this, let me choose this. Okay, I'm choosing both tail, I'm giving okay. Now what do you see here? What do you see here? When Virat Kohli has an average of 58 and standard deviation of 1.5, some value, the 95% confidence limits are 61 this side, 55 this side. Can you see that?
Yeah.
55 this side. This is because of lower standard deviation I have chosen, right? So don't worry about that right now. So these are the confidence limits. Upper confidence limit, lower confidence limit. Have you noticed? I gave 5% outside, isn't it? 0.05. 2.5 this side and 2.5 this side. So these are the confidence limits. So now please note how much chance is there? How much chance is there for the statistics to go outside the 60.94? Can you tell me?
2.5%.
2.5% on the right side, 2.5% on the left side. So totally 5% chance is there for your statistics to fall outside the confidence limit.
Also, yes. 5%.
Now for the same scenario, let me show you graph, probability distribution plot, view probability. Okay. Now everything is here, shaded area. Now I want to find the probability for a particular average. Let's say the batting average is 58. What I'm trying to find here is, see here right tail, I've made it right tail. Can you see? Right tail means I am concerned about the upward movement of the batting average. So what is the probability for the batting average to be 58 and above? I'm giving okay. And now tell me, what did you see in my graph now?
0.5.
5%.
50%.
When the observed statistics exactly on the average, 50% is the chance for average to be 58 and above. When I say, see, probability always requires a range. You can't say what is the probability for scoring 58. You can't ask like that. What is it? You have to give two values. 58 and above. Probability is how much? 50%. This red color zone is the p-value. The red color area is the p-value. This p-value, if it is more than 0.05, you need to understand. If it is more than 0.05, you need to understand your point is inside the confidence limit. 58 is inside the confidence limit. Am I right?
Yes.
Yes.
Your confidence limits were here, but 58 is here. That's why p-value is more than 0.05. This is at the peak. P-value's peak is 50% in this case. Now let me push the 58 to 58.5. Tell me, if I push the 58 to 58.5, what will be the revised p-value? Will it be more than 0.5 or less than 0.5?
More than 0.5.
More than that.
0.5.
58 moving to 58.5.
It's less than
It will be less than.
Let me show you that graph.
It will reduce.
Probability distribution plot. View probability. Okay. Only change I have to do is all other things I retain the same because conditions are same. Here I am putting 58.5. You will see the red color area reducing. How much is the revised area now? 0.36. You should say the difference is significant only when this red color area becomes less than 0.05. When it will become less than 0.05? When your number crosses your confidence limit. Yes or no? What was the right side confidence limit? Do you remember? 61, right? Okay. Graph, probability distribution plot, view probability. Okay. Now let me put a number higher than 61 something. So let me put 62. I'm giving okay now. Tell me what is the probability you are seeing now?
0.0.
Not the 0.3, you have to read fully.
0. Less than 1. Less than 0.5.
Less than 0.05.
So much carelessness cannot make you an expert. 0.0038. How many zeros are there after decimal? 0.00.
20.
Percentage wise is not 5%, it is 0.3% only. This is very, very rare event. Please note, pushing your average from 58 to 62 is a difficult event. Coach has made it. You must give him the credit. Pushing your sales from $58 million to $62 million is not an easy thing, isn't it? Well, unless and until your team is putting the right effort, it cannot happen just like that. But $58 million to $58.5 million will happen just like that. Because market fluctuation, there are many other factors, yes or no? But random factor cannot push your statistics outside your confidence limit just like that. Random, no, but no, still some probability is there. So we put a limit, 5%. But here we observe this particular event is even lesser than 5%. So that's why, and this much risk we are okay to take. So now under this scenario, we reject the null hypothesis. Now, what is our null hypothesis in the case of Virat Kohli and the South African and New Zealand coach? The null hypothesis is the addition of the coach has no impact on Virat Kohli's batting performance. But we realized, we decided to reject that null. That means what is our conclusion? Addition of the coach has impacted positively on the batting performance of Virat Kohli. That is the conclusion. Please note, still there is some amount of risk involved in our decision. That risk is defined by p value. We call it alpha. The maximum permissible risk in any hypothesis testing in general is 5%. That's called alpha risk, also known as type 1 error, also known as false positive. In different domains, they call it different words. In medical world, they call it false positive. Right? A lady is not pregnant, but doctors declare she is pregnant. Happens sometimes, isn't it? False positive. Similarly, your item is good, you still reject your item. Manufacturing, producer risk. Your item is good, you only did the experiment, and you yourself, you reject your product. Same side goal. This is called manufacturer's risk. In hypothesis testing, we call it alpha risk. We call it alpha risk. If the alpha risk is limited to 5% or is less than 5%, your confidence level achieved is above 95%. That is the idea. So this is what I wanted to clarify with all of you. I think otherwise the topic was well discussed yesterday itself. And you are now ready to discuss some case studies on test of averages. If your data type is continuous, you must, the statistics to be used is average. If the data type is discrete, the statistics to be used is discrete. For continuous data, we use average. For discrete data, we use proportion. Now let's understand how the hypothesis testing will be with respect to the continuous data. I think RK should be ready now.
I thought it's proportion first, no? Proportion
Sir,
first.
test of average is enough, sir. Proportion will take it next week.
Oh God.
That's how we do,
Test of average.
Or should I do it?
No, sure. No, average will do it. No problem.
Okay then.
Let me, before that, probably I will ask you a few questions, like Gopal Shokmar. Are you able to see my screen?
Yes, sir.
Yes.
From the beginning. Now, test selection, you will have to give me. I'm not going to give you a hint. For a change, I will be different now. You can compare mean, that is mu, you can also compare proportion P, right? Now you have to tell me what is this. There is only one sample group you are comparing. There is only one sample group for your study, right? What is the test you will use? Tell me. Give the complete test name. Give me the complete. Yesterday only you named it, no? You named your daughters.
One sample.
One sample mean.
One sample mean, very good.
Mean
Because
test.
one sample for mean we are using t-test. Therefore, I will use one sample. Oh God, I'll put all these things. Right? 2 sample groups are there under study. More than 2 sample groups are there under study. So for one sample group, for comparing mean, you have said correctly, one sample t-test. Clear? Now tell me for the proportion, what is the test you will use?
One sample
One sample
proportion
Yeah,
C
for
test.
proportion, what is the test you will use?
Z test.
Z test. One sample Z test. Clear? I have put an asterisk. That is only I will clarify it later. Right? For 2 sample groups, for comparing the mean, what is the test you will use?
ANOVA.
sample t test.
ANOVA.
2 sample.
2 sample T test.
Two sample T test.
Okay, 2 sample T test. Right? And for comparing 2 samples for proportion, what is the test you will use?
Sample Z test as
2
well as
sample Z
the
test. That's all. Now comes to the person who has given me the correct answer previously. Please tell me, repeat the answer now. For more than 2 sample groups, what is the test you will use for comparing mean?
ANOVA.
Very good.
ANOVA.
Now is ANOVA test. And for comparing proportion among more than 2 sample groups, what is the test you will use?
Chi-square.
Chi-square.
Now you know all these tests. How many tests are there?
Also,
totally?
please note the other name for one sample G test under the proportion. It is also referred as one proportion test in literature. Don't get
Very good.
confused.
That's all. Right?
Other name for one sample G test under proportion is one proportion test.
We don't use sample, no? For your understanding, I said use sample.
Similarly,
One
the other name for 2 sample G test under proportion is 2 proportion test.
Very good. That's all. Now,
Just
this
make it up.
one sample T test, we can also use one sample Z test. Okay? Understood? So what we will be using, we are going to compare one sample T test now. Right? We are going to compare one sample T test. Right? We are going to compare mean. Right? For that content and averages only. We are going to compare only these two. One sample T test, 2 sample T test and ANOVA. Okay, sir? So totally 1, 2, 3. Clear? And then 4 also I will teach you. Okay? Understood? Now I'm going to give you problems. 120 out of 1000 usually purchase. Send an advertisement to 1000 houses. 130 of these houses purchased. Now, what is the test you will use?
Proportion.
Very good. That's all. Male purchasers or female purchasers, which is significantly more in a mall? What is the test you will use?
Proportional.
Very good. How proportion? 2 proportion or 1 proportion?
That's a 2
Two proportion.
2 proportion. Male is one subgroup, female is one subgroup. Fat content usually is 15%. A sample study showed 16% fat content. Is there a significant difference due to unknown impact? What is the test you will use? Not fat content. Therefore, it is a average. There is only one sample, right? This is population.
Content is measurable,
Yeah,
continuous.
very good. Therefore, we will use one sample Z test or one sample T test. Understood? Clear?
And what is the difference? One sample G test and T test. When population standard deviation is known to you, go for one sample G test. If whenever it is unknown, you go for one sample T
One
test.
test.
Yeah.
2 lakhs purchase was made usually. Put an advertisement to 1000, just like first statement, first question. But now 2.5 lakhs purchase was noticed after the advertisement. Now, is there an impact because of the advertisement? Significant impact due to advertisement? We need to know. What is the test you will use? What is the test you will use?
Two sample T test.
No, where is 2 samples?
ANOVA, sir.
Where is more samples? There is only one sample, yeah.
There is only one sample.
One
One sample.
One sample, right?
Once.
Okay. Two
One
sample
sample.
t-test or one sample t-test, depending upon the data available, I'll teach you later, right? Now, 4 labs have different turnaround times. Oh, this is not included for you, so that I will stop with this. Now, what I will do is,
ANOVA, that is ANOVA, sir. You can tell.
I can tell them.
ANOVA, that is also test of average.
Here, 4 labs have different turnaround times for lab reports. Is there a significant difference among the lab performance we want to know? What is the test you will use?
Nota.
ANOVA, because more than
More
two
than
labs
More than 2.
and continuous data, therefore ANOVA. Clear? And here 4 regions have sent you your head office wrong applications. Sometimes there are wrong applications, sometimes right applications. Is there a significant performance difference among them? This is chi-square test. Okay, clear? Understood?
Yes, sir.
Please, all of you, please note. First of all, you should understand your Y measure, the response variable. Try to understand whether it is continuous or discrete. If it is continuous, choose one of the test of average. If it is discrete, choose one of the test of proportion. Maybe 1 proportion, 2 proportion, or chi-square. And that's how you should proceed.
See here, this templates also I will give it to you later on. If you understand and if you require, then only. Otherwise, there is no point in giving you full screen.
पानी का ना
Here, the fat content usually is 15%, you say, right? I'll make it as 15. Okay. And then sigma standard deviation is say 2.6. That means we know about the population data. Yes or no?
Yes.
We know about the population.
Population data.
We can use z-test. Now, I have taken about 15 samples. I have taken 15 samples, and the 15 samples have given me a standard deviation of 16. And then a standard deviation of the sample also I can find out. Yes or no? That happens to be 2.7.
Sir, 15 samples are given an average of 16.
16. Understood?
Average of, yeah.
I will make it as 13 samples so that you will.
Hey, all of you listen very carefully, otherwise you will easily get confused. Right now, by mistake, he made a statement. Standard deviation of 16. It is not standard deviation of 16. Average, sample average is 16, right? And nobody bothered to, just ask a question.
I will take
16
it as
is sample
so
average.
sample, what is the sample size here?
20.
What is the sample average?
21.
Huh?
16.
16. Sir, please loud and
15,
tell me,
15.
sir. Then only I can get confirmed that you have understood. What is the sample standard deviation?
2.5.
2.7.
Very good.
2.7 here, right? Okay. You want 2.5, I'll put 2.5, right? Okay, right. So now what we do is, the test is, first what is the null hypothesis? The mean is 15%. Fat content is 15%. That is a
15%.
null hypothesis. What is the alternate hypothesis?
15%.
Not equal to 15.
Not equal
Sample size n is equal to 20.
20.
Now we have to find out Z score. Z score formula I have given here. Mu1 minus mu0 divided by, this is called standard error. Right? What is the n value? 20. What is the sigma value? I know this 2.6. If I do not know this 2.6, right? I do not know. What happens? See here, I can't find out, no, I can't find out Z value. Therefore, I can't do Z test, but I can do T test. Understood? I can do T test. Therefore, T test is called a approximate test. And if I know this population, I will do test. Okay? Understood?
Yes.
Degree of freedom is 1 minus the n minus 1, that is 19. So that
19.
you can take this n samples, you can go to some data, right? Input data is there, no? Here, see, I put the 15, I'll put some values, no? Control C. Control V. Oh God, I protected, right? So I can change here. What I'll make it as 15, 16, 18, 17, 12, 13, 15, 20, 19, and 8. See here, now you know what is mu1, S1 and N. Yes or no?
Sir, here that sample is, you need to take 20, na, sir?
You want to take, you take add on.
Uh-huh.
9,
But in
25.
the example, we are saying about
10 samples.
No, you will have to put the data here and get these values. That's what I'm saying. Understand?
So he's asking number of samples 10, 10 one, right?
Now I will put 10. If you want, I will put 10 here.
Okay, okay.
I will put 10 here. What is the values we have obtained? We will get the data, input data for 12 data. Now 12 we will put. Number of data is 12, 15.6, 4.76. Right? You tell me, remember that and tell me that. 12, 15.6, 4.76. Remember? 12, and then
15.6.
15.6.
15.6 and 4.6. You have to tell, yeah. So you get this value, fail to reject the null, right? Both are same like this. That is what it is giving, right? Because mean is 15.6, right? Suppose the mean is 13. See, reject the null, right? Because I said Z is more important. Therefore, I have to go by only Z test. So I will make it as here 3.5, right? Reject the null. I'll make it as 4. Fail to reject the null. Both are same, right? Therefore, this is how you go to the input data, find the sample size, mean of the sample, standard deviation of the sample, put the values here, put the population data, you will get the sample mean results. And the conclusion also is there. Claim in the null hypothesis is accurate. What is the claim? Null hypothesis, this is the claim, right? Mu naught is equal to 15. This is accurate. Otherwise, claim in the null hypothesis is inaccurate. Suppose I will put it as 12. I'll make it as 20. And mu is 12. See, claim in the null hypothesis is not accurate. Okay? Understood?
Yes.
If the standard deviation more than this, also it will not be accepted. Right? If it is less than this, 5. And if it is 14, it's okay. That's all. The data you substitute here in the input data, get the mean and standard deviation, go back and put it and you get this. That is what is
This is a beautiful template for one sample G test and one sample T also we can do, sir, here itself.
one sample t-test we can do it. Not in this. I will give. I will show you.
Okay,
that.
another template.
Yeah.
So this template is used for one sample G test.
This
For
is
use-
used only for one sample mean test, 2 sample mean test, and 2 sample summary mean test. I will tell you 2 sample summary mean test because you know how to get the summary. You know what is summary? Mean and standard deviation is the summary. If you know the sample statistics, that is number of sample size, mean, and the standard deviation of the sample, that means you can use this 2 sample summary. If you have the data as it is, no, I will show this.
Yeah.
Yeah.
If the raw
You
data
put
is
the
not
data here,
available,
it will give you
you
the
go for
value.
summary.
See, you put the data. This is called raw data, right? This is not raw data also, yeah. The raw data is something more. I will tell you later on. That is, you have to use a code, right? You will use a code to convert this raw data into coded data, and you can put it here. Here, this is actually data available here. You can use it for the number of. See, I suppose I'll put here. Here, number of data is 10. No, I'll put another data 850. See here, it has become 11. Right? It has become 10. I will add a data here also, 855. See here, it is also so that you can keep on adding the data here. It will find out the average itself. It will find out the standard deviation itself. And then it will compare. Please note here, what is the null hypothesis is here? Null hypothesis is mu naught is equal to
822.
I do not know which one to use. Yes or no? So I will add this. This is what the formula I will use, right? Okay. There is no difference in the performance between the centers. This is the null hypothesis. And H1 is there is a significant difference in the performance of the centers, right? Mu1 minus mu2 is not equal to 0. And then you can get the result. Well, depending upon this is the conclusion, this is the condition for conclusion, and this is the conclusion, right? Claim in the null hypothesis is not accurate. based on the p-value. P-value is obtained here 0, right? Therefore, it is significant. Reject the null. We have rejected the null. So you can keep on adding the data here. You can take the data from this input data here. You can put on the data and then copy it there. You can put on the data and copy it there. And then you can do it. If you know the values here, substitute the data here, get the value of mu1, s1, n1, get the values of mu2, s2, and then you can substitute here. Here. See here, all you need to do is, what is the number of data in the sample 1? What is the mean?
This
What is the
alpha value will
standard
be the same
deviation?
for this 1Z and 2Z.
Alpha value is
Alpha.
always fixed universally 5%. If you want, you can change it here, but don't do it.
Because how we can define as a, is there any variance will come depend
No,
upon
no,
that?
general practice is 5%. Alpha is 0.05 unless specified. That means your confidence level aimed is 95%. If you
For
want more
that-
confidence, then your alpha value should be reduced further. You want 99% confidence, then alpha will be 0.01.
Okay, sir.
You want 90% confidence, then alpha will be 0.1. Clear?
Clear, sir. Clear.
Alpha value determines the confidence level which you want. People want 95% confidence always, but generally some cases they want 99% confidence. Understood? So you'll have to put 99% or 99.5%. Right?
Sir, one more, sir. Sorry for. In case of
No
you are
problem.
taking
Please
as a systematic data, it has been automated data is there. In this, we can take his alpha value is 99% or is manual data any.
Alpha value is something which you fix. Yeah, you fix any damn value, even 0.1 also you can fix.
Okay.
Nobody questions, but everybody
Yes,
will question.
Point will come when we are making any statistical. Most of these observation will make the system will be give the accuracy of.
No,
accurate
please
data.
wait, please wait. See, alpha is not a calculated value.
Yes, sir.
It is fixed value. We are fixing in our decision.
Yes, sir. Yes,
In our decision, we fix that our confidence level is 95%. That means our alpha is 5%. We are fixing upfront. See, any research, any study you do, you have to tell people your confidence level and level of significance. Otherwise, your study is, people will not be able to understand the worthiness of your study.
Yes, sir.
A study, a new finding without alpha and confidence level has no meaning at all.
Yes, sir. Got it. Thank you, sir.
Right?
It is like my fixing the pass mark for you. We have fixed 60%. It is up to me. I can fix 10% for you and make you pass. If I like you so much. Right? So people will question then, hey, what is this RK just like as put in, right? We give
That
grace
means
marks.
40% error is tolerable for us. Do you understand? 40% uncertainty we are fixing. Our confidence level is only 60%. Can you see that? If we want to increase the confidence level, then we have to reduce the error percentage.
Okay, sir.
If I keep the error percentage as 5% and keep the pass mark as 95%, do you think all of you will pass?
No, sir.
So we want more candidate, right? So that's why we are okay with higher level of significance, higher value of alpha.
Thank you,
And
sir.
in the year 2015, all of you, do you know Maggie was banned in the year 2015?
Yes, sir.
Yes, yes.
Can you tell me the reason why it was banned?
Monosodium, sir.
MSG, very good. Monosodium glutamate was
Glutamate.
found to be present. And one more reason is lead content.
Yes,
Yes.
sir.
And the decision arrived is 400 million packets of Maggie was destroyed.
Yes, sir.
Yes.
What is the quantum? 400
400
million
million.
packs. Do you think they have checked all 400 million packets for monosodium and lead content?
No,
No.
sir.
No.
The batch
They
has
don't-
How many packets? How many packets?
They done the sampling like
Randomly they have
selected
sampled.
samples and they done the testing and they evaluated.
Random sample of
Random
10,
sample, yes.
50 or 100.
Yes, yes. Randomly they have checked.
Let's be on the safer side. 100 sample. Now 100 Maggie packets were tested and 100 data about lead content will be available to you. Am I right?
Yes, sir.
Lead content, is it continuous data or discrete data?
It is a discrete data,
Continuous.
but there
Continuous.
will be the variation.
No. Wait. Lead content. Lead
Content.
content is one thing. MSG is other thing. Lead content is measurable or not?
Yes.
It is a measurable.
So continuous data. You are studying a sample and you are judging a population. It is one sample test. It is one sample test. You don't know anything about population, am I right? Except the specification that is mentioned. That specification is the average, but standard deviation is unknown. Whenever population standard deviation is unknown, population remains an unknown population. For unknown population, you should go for one sample t test. For known population, you should go for one sample g test. So what is the differentiator for known and unknown population? The standard deviation of the population. If the standard deviation of the population is known, you can call your population as known population. That's the time you go for one sample G test. In the Maggie case, do you think population standard deviation is known to the investigators?
No, sir.
No.
So unknown
No,
population. So
Unknown
their
population.
option is limited to one sample T test. They performed a T test. They have observed a p-value of less than 0.05. So they rejected the null hypothesis. What is null hypothesis? Lead content is as per the spec. The practical conclusion is they have decided to recall and destroy all the Maggie packets. See, statistical conclusion we are teaching here. Practical conclusion you have to take in the field. If you are the food inspector, what is the decision you are taking? You are deciding to destroy 400 million packet. You remember, you see how big the decision is. But how did you arrive on that decision? Because you are able to reject the null hypothesis. The null hypothesis is the company's, what do you call? Company's commitment. They say lead content is within the range. That is null. You want to go against it. Please go against it only when your p-value is less than 0.05. Do you understand? You can do that at an alpha value of 0.05. You can do that at an alpha value of 0.01. That will in turn will decide your confidence level on your action. Clear?
Yes.
Clear.
If population standard deviation is also given to you, same situation will become one sample,
T test.
not T, G test.
G test.
Now look at Dr. RK's formula of one sample G. Sir, show that, sir. One sample mean test.
Yes.
Can you see the formula for G and T? What is the difference? In the place of sigma, what are you seeing?
S1 is a sample.
S is sample standard deviation. When company is not willing to share their standard deviation, in that place you can use your sample standard deviation. But this is, an approximation. Isn't it? If company shares, if the population data is available, population standard deviation is available, then your decision becomes more accurate. So comparatively, G test is the best. But if the situation doesn't allow, you need to go for T test. Hope it is clear to everyone.
Yes, sir.
Now I want to understand whether RK's teaching is better or Vivek Kumar's teaching is better. What is this test?
Sir, we just come.
Attribute or continuous?
RK's teaching is better or Vivek Kumar's teaching is better. I need some performance variable, right? Let me tell you your test mark. I conduct some test on RK's portion. I also conduct some test on Vivek Kumar's portion. Now test mark. Tell me test mark belongs to which kind of data?
Continuous.
Continuous. So what is this test I am doing now? I am comparing two faculty members here.
Two sample T test.
Two sample Z test.
Two sample T test.
Yes,
Beautiful. You are becoming above average professionals. Now you are able to choose the right tool, isn't it? You have a daughter and a son. You want to compare their performance in studies. What is the test you are doing? Two sample test. And try to understand the metric you are using. Are you using their test mark? Or are you using their number of certificates they achieved? Number of certificates means it's a discrete data, isn't it?
Yes.
Test mark means it's a continuous data. So you have two suppliers. Both of them supplying raw material. Let's say aluminum ingot. The particular characteristics of the aluminum ingot. Let us say the strength of the aluminum ingot. Strength is continuous data, isn't it?
Yes.
And you want to go with the supplier who can give you a better strength. the higher strength. Whoever is maintaining a higher strength, you want to go with that supplier and cancel the contract with the other supplier. Now, what is the test you are performing?
Two sample t-test.
Two sample t-test. Imagine you have a standard expectation. The strength should be 400 Newton per mm square. That is the reference value. And a supplier is approaching you. Whether you want to select him or not. How will you select? You take some sample and check whether the strength is more than 400 or not. Your 400 is the reference value, isn't it?
Yes.
Now, what is this test called?
Sample Z test.
What is that?
One sample.
One sample test.
One sample test. One sample
And
test.
G or T. It is only T. No supplier
No.
will share all the complete data with you.
So I'm going to sample test. So going to t-test.
So population characteristics will not be revealed. They will only say that strength is 400 Newton. They will never reveal the standard deviation, isn't it?
Yes.
So you will be performing one sample t-test.
T-test.
Suppose within your company, in a department, you want to check something. Within your company, your department is producing a material and the expectation is 400 Newton per mm square. But all the past data is available. So far, the information is available. That means population average, population standard deviation is available. And now you take a sample and you are studying whether the parts are complying to the strength requirement. Since this time the standard deviation is known because it is an internal test, you can be more accurate. What is the suggested test now? One sample.
G test.
Z test.
Z-test.
Sir,
Clear?
one question, sir. So we are, as you said, if population standard deviation known, we'll go for the one sample Z test. For example, every last 3 years data I have, but the 3 years I am doing sampling only. Like sample. But when you see that long term, it is 3 years data. There are huge data. So it is population or sample data? Because population may discover all. So how we can?
Sir, can I come, sir?
Yeah, please, sir. Please answer.
Please note, you are going to take data in future also. Yes or no?
Yes.
So even if you take all the data from the beginning till the end, then also it is not population. Yes or no?
Yes.
So there is no population existing, just like that in your case.
Okay.
Therefore, what you consider is the population. For me, this class is the population.
Yes.
And for me, if I want to compare this group and the previous group, both the groups together is called population. So
Whatever is your understanding so far.
Like if I don't have coffee powder in my house, what do I do? Yeah, I go and borrow from my neighbor. If he doesn't give that, what I will do? I will get a tea. That's all. Z is coffee, T is tea. Right?
See,
if you have
whatever
data,
is
use
your
D. Otherwise, use T distribution.
whatever is your company's understanding so far, that is known as population characteristics. With the best of the knowledge available, I know that last 10, 20 years data available, maybe sample or maybe whatever it is. My company believes that this is the characteristics. They have some data. That should be considered as the population characteristics.
Excellent.
Now you take 10 sample, 20 sample. Now that is sample. This sample is compared against your long time belief. The population, please note all of you, the population characteristics are called as parameters.
Parameters, yes.
Parameters are only two. One is average, another one is standard deviation. Average, you should use the symbol mu. RK was showing you, isn't it? Mu.
Yes.
And standard deviation, you must use the symbol sigma.
Sigma.
And now sample. Sample also will have a characteristics. The sample characteristics are known as statistics. And again here, mean and standard deviation. Sample mean is X bar.
X bar.
Sample
Capital
standard
S.
deviation is capital S.
Capital S.
With the help of X bar and S, you are trying to understand mu and sigma.
Yes.
Isn't it? Sometimes you compare X bar and S against mu and sigma. You are trying to understand whether this sample is compliant to the population requirement or not. Clear, all of you?
Yes.
Clear.
So use the language wisely. Whenever you are using the word parameters, you are talking about your population. Whenever you are using statistics, you are talking about the sample. You are using statistics to comment on the population. This is called inferential statistics. You are studying statistics. With the help of the statistics, you are judging the parameters. This is what is known as inferential statistics. In every field, it is used in cricket, isn't it? In sports, all sports, manufacturing industries, non-manufacturing industries, pharma industries, even in marketing and sales, you can use. As long as you are very clear with the basics, you can use it in sales and marketing. You can predict, forecast sales, right? Past history is our sales track is our company on an average maintains let's say 50 lakhs annual sales. What is this 50 lakhs? Population average. There, according to their understanding, the monthly sales is how much? 50 lakhs, isn't it? And based on that, they set some target and etc. And whether that is happening or not, they have to conduct a study and then compare. Right, sir? I think we can go ahead.
So what was my portion topic today?
We can now go to ANOVA or to sample t-test.
Okay. We'll go to ANOVA.
You're on time.
Very good. What I will do? I don't know. How to come to the? Yeah. I will come. So I'll share my screen. So what I will do is I will close this. I will close this also. Don't save, no? Don't save. No, save. I may change this. Save. Okay. So, are you able to see my screen?
Sir.
Yes or no?
Yes.
But how do I close this? Yes. Save. I will, yes. ANOVA test we will go for, right? See here, ANOVA test, we are comparing here, mean. There are 3 subgroups. How many subgroups are there? Mean. Therefore, when we want to compare average for more than 2 groups, we use ANOVA test, right? Before that, I will tell you about there are different types of ANOVA tests. I will tell you what are they. Yeah. There is a jargon here. Control group and treatment group, right? Control group is what is usually happening. That is called control group. What is normally happening? Generally, my water bottle contains 800 grams of milk means that is a control group. Treatment group means what is the new value I have noticed from the sample, that is called treatment group. Therefore, keep this in mind. See here, I'm using method and then treatment, right? Method is one factor, treatment is another factor. This is called 2 factors, right? And then in the method, for each treatment, I am taking repetition of readings. I don't want to. Therefore, this is not for you now. Black belt we will teach you. And then I am using the non group. Both are same. I can use treatment or group, right? Different people use different jargons. And method, I'll read it as method. I'm taking only 1 reading for each group, right? For 1 method, for 2 method, second method, third method, like that. This is called just 2-way ANOVA. In the third one, this is the one we are going to compare. We are going to compare 3 different treatments, 3 different laboratories, or 3 different companies or vendors or anything, right? And I'm taking readings, 1, 2, 3 repetitions I'm taking, right? This is called 1-way. ANOVA, 1-way. Clear? Understood?
Yes.
This is called 1-way ANOVA. What is this called? 1-way ANOVA. We are comparing only 1 factor. Each factor is a variable. Please note, you know what do you mean by variable? This factor have got different levels, right? Group 1, group 2, group 3, like that. Male, female. Gender has got is a factor. it has got 2 levels or 3 levels, right? Male, female, children, like that. Understood now?
Yes, yes.
Or no? You just give me an example, yeah. Where are the one-way ANOVA can be used? Tell me. One-way ANOVA can be used. Where? One-way ANOVA. Where? Tell me a problem. Give me a problem where you can apply this ANOVA.
Want to buy
For
it? There are different brands will be there.
For
Different?
example,
In
Different?
the brands will be there. If you want plan to buy a TV on that thing, sir.
Yeah, yeah.
Purchase a TV. There are different brands will be there. There is a more
Very,
than,
very good. Different brands, right?
yeah. So when we are comparing the sizes, if everything is fixed to our requirement, we just comparing with the 3 brands and the features will be taken into the
Yeah.
ANOVA one.
Yeah. Now, suppose in one session I keep mum, and another session I keep on talking, and then afterwards I conduct a test for you too, right? Third one, right? Me along with Gopal Kumar. You want to find out which one is better, me silent or me talking alone or me talking with Vivek Kumar and Gopal Kumar. Which one has got more performance? You want to find out. I know what test can be used. Yes or no?
Yes, sir.
Something
Yes,
crazy ideas, yeah. Crazy ideas you think of. And that is the way you can create thinking, right? Understood? Now, water. Water. See, suppose I want to wash my clothes, dry my clothes. Should I wash it in my warm water or hot water? Hot water or cold water? Cold, warm, and hot water, right? Cold water or ice water or warm water, like that. I should use
No
powder,
test.
soap or thick soap or in between soap, right? Or no soap. Clear? Or more than 2 groups, if you get no, each factor has got more than 2 levels, then you use for ANOVA. Clear?
ANOVA.
Understood?
Yes, yes. ANOVA test.
Now I'll
That
go
will use
for
3
1-way through groups.
comparison.
See here, I'm comparing vendor A, vendor B, vendor C.
Yes.
Right? Vendor A, vendor B, vendor C. I'm giving orders to them. Ask them consultancy. They immediately give you some responses. How fast they give me the successful response, I'm noting down. This is a time, days, or whatever be it. Some time I'm noting it. 3.37 hours, 7.57 hours, like that. So whoever gives me fast response is the best vendor. Yes or no?
Yes.
This is called transaction time. So I'm noting down transaction time for vendor A, vendor B, vendor C for the last 1 year. So many data are there. You can see here so many data. How many data? I do not know. Yes, 120 data are there. It can be different also for each one, different maybe. So you can see here count is 120, right? If I remove some data, then this two I will remove, delete. Then see what happens. It has gone to 118. So it counts automatically, right? I'll change it. I've added it. Now it will become 120 again. So 120. And the total of this also it is giving. If I change it to 4.17, it will be 686. Note down. 4.37. It will become 686. See 686.67. Right? If I go back, it will 684.7. Therefore, this is totaling out, counting average of this divided by counter. And then variance. You know how to find out the variance. That also it is calculated. And then, please note here, between groups, between vendor A and vendor B, within groups and the total variation for the entire data, and the difference between this is within the group, sum of the squares, right? And degree of freedom, it is calculating for 3 groups, 3 minus 1, this within group 357, it is finding out. And then mean square, sum of squares divided by degree of freedom, and then it is calculating F value. Based on F value and the degree of freedom, it is calculating P value, and based on P value, the decision is given here. Based on the decision value, you can make the conclusion whether they are performing same, all the vendors, or there is a significant difference in at least one of the vendors. There is a significant difference in performance in at least one of the vendors. Right? Or at least difference in performance at least among the 2 of the vendors, right? Clear? This is how it is calculated. Now, suppose I change it here. Suppose I want to make it as say 8. I will make it as 8 here. Once again, Control Shift down. Control C. I'll take a place. No, I can't take a place also. Okay, I will, doesn't matter. I will take a risk. I will make it as 8. Right? Purposely, I am making this vendor different. Right? You will have to see that, reject the null. See, you got it, reject the null. Yes or no? P value has
Yes.
become close to 0. Is it not? P, what is the P value? 7 into 10 to the power of minus 9. That means 7 by 10 power 9, which is close to 0.
10 power
That is
9.
reject the null. Right? But change this. See here, fail to reject the null. Because this is 0.09. Right? More than 0.05. So depending upon whether the P value is more or less, you take the decision. Based on the decision, you make a conclusion about the null hypothesis. Please note, in all the hypothesis statement, we take a decision only on null hypothesis. Don't tell that reject the null, alternate, fail to reject the alternate. No. Either you reject the null or fail to reject the null. That's all. Understood?
Yes.
Clear? Let me see if there is a video here. Once again. I'll play the video here. Yes. Are you able to see this? Hi. Today we will see ANOVA test. That is hypothesis testing for more than 2 groups. Types of mean test we will see first. Types of mean test, we can show it here, visualization. When there are a group and a population, we use t-test or z-test for comparing mean. When there are 2 groups, we are using t-test for comparing the mean. And when there are more than 2 groups, group 1, group 2, group 3, and for comparing the mean, then we use ANOVA test. There are 3 types of data we can take, and then we will use different types of ANOVA tests. Suppose we have 3 groups. Groups and treatments both can be used. That is, treatment also I can refer it as group. Group 1, group 2, group 3, or treatment 1, treatment 2, treatment 3. And then I am taking readings for each treatment. And this is called ANOVA one way. And then if there are different methods in each group, then for each group there will be different methods. Method 1, method 2, method 3, and like that. Then we are taking the readings. Then we want to find out which one is the best. Or are they same, right? And this is called ANOVA two-way. But in order to overcome the noise factors, what we do is we take different readings, replications, repeat the experiments, repeat the trials, I would say, right? Because the entire thing is called experiment, and each one particular test is called a trial. So reading 1, reading 2, reading 3, 3 readings for each method, right? We are using. This is called ANOVA two-way with replications. We will see one by one how to do it. See here, first we will go for ANOVA one way with 3 groups. Here is the data here, and hereafter, and you will get the result here. All you need to do is fill up the data here. I have filled up the data. What I will do is Control Shift down. I'll Control Shift down. I'll delete it. You can see here count is only 4 because there are only 4 datas are there, right? And the average is calculated and fail to reject the null, right? So what I will do is I will replace the data. You can see here 120 datas are there provided, and the result is fail to reject the null. That is, all the 3 groups are same. There is no deviation here. Suppose, for example, I will change this 5.1 only. I will copy it, right, throughout. Then we will see what happens. See here, reject the null, because this is particularly a different one. This is varying from the remaining groups. So this is how you go for one-way ANOVA test. And if there are 4 groups, do the same thing. What I will do is I'll just copy this 6.454 here. See here, and you can see here, reject the null here, because this is deviating from the others. All are not performing at the same level. So this is how you do one-way ANOVA. I think that completes ANOVA also.
Yeah. All of you, are you clear now with respect to the ANOVA test? Do you now understand when to perform ANOVA? Have you ever come across such a scenario? Are you doing any study, any research? See, ANOVA is very, popular, widely applicable. Many research thesis and many research projects, it ends with ANOVA.
Yeah, let me teach you Excel method also, sir. I will teach them Excel method, which is
This
simple.
template method is fine, sir. We can, template method is fine. Now let us clarify their doubts first. So all of you tell me, now do you understand when to perform ANOVA? Can you give me an example of ANOVA scenario?
Well, for vendor comparison,
Vendor
four
comparison,
vendor
very good.
comparison. Yes.
So why are we switching from two sample test to ANOVA? When there are three vendors, why don't you, handle the scenario with the two sample test? You can take two vendors at a time and do the two sample t-test, no?
Yes.
It's going to be time consuming, isn't
Time
it?
consuming.
If there are three vendors, A, B, and C, AB, one two sample t-test. BC, another two sample t-test. CA, another two sample t-test. Because three combinations possible, isn't it? So every time you do an experiment, there is a chance for certain error, isn't it? That is what
Yes.
we
Yes.
are measuring, the type 1 error. So every time there will be error. 3 times committing type 1 error is okay, or doing it one time is okay. Doing it one time is okay. That's why we have upgraded the procedure from running several two sample tests to one time ANOVA. Clear, all of you?
Yes, sir.
Yes.
Now I want all of you to make a paper plane. I will give you a design. I will give you a design, and what you need to do, you have to make a paper plane. After making the paper plane, you have to fly it. You have to fly it. How many seconds the paper plane is in the air? And whoever makes a paper plane, which can fly for the more number of seconds, you will get 10,000 rupees.
Mm.
Clear, all of you?
Yes.
Now, how many people are here? With excluding me and RK, there are 18 people here. Am I right?
Yes.
And the prize money is 10,000 rupees. And 10,000 rupees, we can't, what to say, blindly give it to someone. We have to be very, very
Yes.
clear that that person is really capable of performing
Yes.
the task.
Yes.
So we actually did an experiment. We gave you 10 A4 sheets so that you could make 10 planes, and then you could fly and record the video and record the time. And now you have 10 readings. Each one of you will have a 10 reading,
Yes.
right? And now the
Sure.
average of the 10 readings will be the average flying time. And whomsoever average is significantly higher, I will give him that 10 rupees. I'm sorry, 10,000 rupees. Now, what is this test? Just now I
Innova
performed.
test. Innova test.
You understood ANOVA, that's all. Right? When there are only two people, I do the same thing. It is two sample t-test. Of course, in a two sample scenario also, ANOVA can be performed. The only difference is procedurally, there is some difference. You don't have to worry about everything in the beginning. At a later point of time, you want to deep dive and do a lot of research on what is ANOVA and all of this. That time you come back to us. Right? Master Black Belt. We will convert you into a trainer, but not now. Now it will become a overdose, right? Don't research about the formula. Formula is developed by statisticians already. Let's just follow the procedure. Right. After you all make 10 planes, I am putting a condition. Every plane should fly minimum of 30 seconds. Every plane should fly a minimum of 30 seconds. So whichever plane flies for more than 30 seconds, that is considered a success. Whichever plane that falls down below 30 seconds, that is considered a failure. And whoever maintains a higher success rate, he is now going to be declared the winner. Now, what is this study? What is your data type now? You are measuring
Two samples.
success and failure, isn't it?
Two samples.
No numerical values. You are only noting down success and failure. How many? Only two possibilities. What is your data type now?
It is more than two groups, sir.
10 groups. I mean, 18 people, all of you.
Chi-square.
Discrete data only.
Chi-square. Because your data type has become discrete and you are comparing the success rate. One person is maintaining 90% success rate, one person is maintaining 80% success rate, one person is maintaining, 70, things like that. And we just compare proportion. Percentage is nothing but proportion. Proportion success, proportion fail. So that is a chi-square test. So now you are very clear about ANOVA, very clear about chi-square. Can you give a practical application of chi-square? Have you ever, faced this scenario similar to chi-square in your workplace?
So for example, we are collecting the data uh, in terms of whether this remote teaching or classroom teaching. Which one is good?
Remote teaching and classroom teaching. Okay.
Yes,
So
yes.
here,
And what do you study in remote teaching? What do you study? You study their marks or study their pass percentage?
no, not pass percentage. Just we are taking survey from the people. For example,
Okay,
whether
okay. Oh,
satisfied, unsatisfied,
very good, very good. So that is also
like this.
discrete only. So
So,
percentage of people who said satisfied, percentage of
so
people who said not satisfied. You are comparing against two types of what do you call two types of groups. That's that is again a proportion test, and depending on the number of groups, if there are only two, we call it two proportion test. Good. Imagine you have three lines of three production lines in your company, and every line there is some rejection percentage maintained. Right? Same line only. I mean, same product only, but you have how many lines? Three lines. Now you want to understand whether any particular line is giving you more rejection, and you so that you can actually work on it. Now, what is this study?
so the rejection it will come in numeric. So it will be ANOVA.
See, all numerical data are not continuous data. Your discrete data also numerical only.
Yeah.
So you can't classify that way.
Chi-square, sir?
Percentage
Chi-square.
rejection.
Chi-square.
Chi-square.
Percentage rejection is a proportion rejection, isn't it?
It is a numerical value.
If I say rejection is 5%, 0.05 is the proportion of defective item I produce.
Okay, then,
Isn't it?
sir, for example, same earlier example, I said satisfied, unsatisfied, significantly. Okay, this we can convert into the number. For example, I'm giving the rating. Satisfied 5, unsatisfied 4, 3, like this. Then I convert it to number. Then now it will be the numeric. So I can able to take average and everything. In this way, we can apply ANOVA the more than two groups.
So it is we are comparing only.
See,
Is it right way
you
or
can calculate average.
I give rating like satisfied,
But
over
basically,
satisfied.
your data type is when you ask people to give a rating 1, 2, 3, 4, 5, you are giving only 1, 5 possibility.
Correct, exactly. Yes, yes.
So that is discrete data only, no doubt.
Okay, okay, okay.
Now,
Uh,
how many people, what percentage of people gave 5? What percentage of gave 4? What percentage
okay.
of gave 3? That is the best way of understanding your
Okay.
data.
So chi-square is correct.
But you still want to calculate average and then compare the average. You know that there is a limitation in your data, and then with that you calculated the average, and you can perform ANOVA and make some decision. But within your data there is some limitation. It is not a measured data. It is actually a kind of discrete data.
Okay.
So, but there is a
Yes.
limitation. But still, sometimes people do that. You can convert that into ANOVA. That means all good so far. Now we are ahead of the schedule. That's fantastic. That means you people can ask a lot of questions, all challenging questions, but we will try to answer. So any other doubt? You are now very clear,
Hello,
right?
sir.
Venkatesan?
Sir,
Yes,
sir,
please.
actually, I have one footwear in footwear industry. Okay, sir. It is called three type of footwear fitting. In different type of models. Okay, sir. How to
Your voice is
it
breaking.
will get it
Your
that some defects from. Hello.
your voice is
Sir.
breaking. You are saying three types of footwear.
Okay.
Maybe your voice is breaking. You off your maybe you can
I'm
try.
using phones that way
Ah,
only.
now you speak.
Sir, three type of footwear I am using. Footwear some example for sandals, some
Okay.
V strap and closing type. Okay, sir.
Okay.
In 1 month, I have target for 15 samples like that. If I get
Okay.
it that 15 sample, different type of damages will be came there.
Okay.
Which type of theoretical, which type of topic I would be
Yeah,
use
yeah.
from that.
So different types of damages. So different types
Yes,
of
sir.
damages means you it's a countable information. Am I right?
Yes, sir.
How many different types of defects in a footwear? You need to tell me what are the
Yes,
defects
sir.
normally possible. The strap coming out,
The simple, sir.
right?
Say, open type of footwear and stitching broken something in a
Something like
sole
okay.
track something.
Okay. So all of this stitching issue, peeling issue, color issue. So it's actually a
Yes, sir.
countable information. And since you mentioned there are three
Yes,
types
sir.
of footwear, you want to compare one against each. Which one is giving minimum stitching issue, or in which case the stitching issues are more? That is a case of chi-square test.
Chi-square. Okay.
That's a case of chi-square test. Please make sure more than all the tools, our common sense is the best tool.
Okay, sir.
Our common sense is the best tool. If your common sense is straight away supporting something and you still perform a test and try to agree to the opposite of it, you may commit sometime blunder. So
See,
keep
can I
that in
come,
mind.
sir?
And one more point, sir. One more thing is the quality of your data is also very, very important.
Yes, sir.
Simply, you collect data in all wrong manner and with insufficient sample. And just because you performed a chi-square test, you may not be correct. Do you understand? That's why I told you use your common sense. Your common sense should also support your decision. Imagine you have 10 lakhs, you want to deposit 10 lakhs in an investment plan. Will you
Yes,
use
sir.
common sense or will you use some recommendation from a software?
No, sir. Only common sense.
Definitely your common sense should support the recommendation, isn't it? Otherwise, you will not put your 10 lakhs.
Yes,
Software
sir.
is telling you invest. It is an AI-based investment. So 10 lakhs will be doubled in 3 months. But you still believe that your money is under risk. So you will avoid investing, isn't it? So same logic has
Yes,
to
sir.
be used in your workplace also. Okay, sir, over to you.
Yeah. Please note, whatever we do, no, we are doing the same thing, no? We are taking the same decision. Like whatever he says, we are doing it in a different place also. Can you identify? The same thing, we are doing it in a different place. Whatever he was telling, three different brands, three different defects, we want to find out. What is that you want to do it, you should know. You want to find out, identify the problem or find out the performance difference. If you want to find out the performance significant in difference, you use this test. Otherwise, what you are doing is same as this, but it is called Pareto chart. Identifying the frequency, which one you want to identify and sort it out, right? So that you
Right.
should have your clear mind in what you are doing, whether you are identifying the problem, you are solving a problem, or you are finding out the difference in performance, right?
Yes.
The same thing you do it differently on different occasions. But which one is easy to do it? Which one should be done? No? I can't scold my wife. Yes or no? Tell me, yeah.
Yes.
I can never
Yes,
scold
sir.
my wife. That's what simple. I can scold my children. I cannot scold my children even in front of my wife. These are all the different things I must use in my mind. Otherwise, I
Aman,
will fail in my life. Similarly, you will fail in your life if you do not know. Apply your smartness. You are smart. You know this can be used for Pareto chart. You know this can be used for ANOVA. You know that this can be used in even the final stage, control stage, right? What is that we are doing it? You should know how to do it. You should know, and you will have to dedicate. That's it. Thank you.
And see, this Excel file I have shared with all of you already. And this contains a lot of data. Let me pick up something here. What is that? Fat content. And fat content, yeah, cooking oil fat content. You see, the same data is available here with me. I want to check whether the fat content is as per the spec or not. Oh God. And what is why it is not coming? Okay. So we need to check whether the fat content is as per the spec or not. What is the spec? Company claim is fat content is 15%. Now tell me what is the hypothesis testing I should do now? Company's claim is 15%. I have some sample cooking oil. The fat content I have measured, and now 13 samples I have that 13 sample of data I have. What is the test I should perform now? Come on.
T-test.
One sample t-test.
One sample T-test. One sample.
Beautiful. Now the null hypothesis. What is null? Come on, tell me.
Fat content.
15%. And my doubt is alternate. So null, what is the symbol? H0. Alternate H1. And my doubt is fat content is more than 15%. And data are the response variable. Response variable means the Y variable. What is Y variable here? Fat content. Content is continuous time. Right? Since it is continuous, I should use statistics for decision making. What is the statistics I should use for decision making? Yes or no? Yes or no?
Average
So,
value.
so this leads me to test of averages. Now I compare sample average against the reference or population, I can say. And so this is clearly letting me understand the test is one sample t-test. Am I correct?
Yes.
So I have to perform now. So I go to stat, I go to basic stat, I go to one sample t. The description is also confirming that. Determine whether the mean of a sample differ significantly. All of you please note, you are performing hypothesis testing only to use the word significant. Then only you can use significant. Only when p-value is less than 0.05, you can use the word significantly higher, significantly better, significantly different, significantly lower. So what is the requirement for using the word significant? P-value should be
High.
less than 0.05. So I click this. Now one or more sample in a column. See here, summary data, RK was saying. Summary is, if summary available, use that. Otherwise, data available, you come here. Now click. Now fat content. Oh, I have given two names, so don't worry about it. Consider that as a fat content. Now perform the hypothesis test. What is the hypothesis mean? Hypothesis mean is nothing but the company specification. Company specification is 15%. Option. Confidence level. Confidence level. How much confidence you want? 95. That means what is the alpha you are fixing indirectly?
0.05.
0.05. If I change it to 90, then alpha will become 0.1. Change it to 99, alpha will become
0.09.
0.
normal way procedure is, normal practice is 95. What is your alternate? You want to conduct a right-tailed or you want to conduct a two-tailed? Tell me, what is that we defined? We are interested in checking right-tailed only, isn't it? Whether our mean is higher than the specification, because higher fat content I don't want. I want the fat content to be 15 or below, but higher value is the problem. So I keep it right-tailed. That means my test is one-tailed test. There are certain, what to say, the tabulated values for every test. If our t-score crosses the tabulated value, then it is significant. So instead of using that method, we use the p-value method. So I give OK. Again, I give OK. Now Minitab has done the job for me. Look here, one sample t-test for the fat content. test of mean equal to 5 versus more than 5, that is right tail. And see here, sample mean available, sample standard deviation available. There is something called standard error, and standard error also we will speak to a little later. Now, what is very, very important is p-value. Tell me, how much is your p-value?
0.008.
Point 008.
0.008. Now tell me, is it less than 0.05?
Yes, sir.
Significant.
Yes. That means what should you do?
Significantly.
Reject the null. Reject the null is the statistical decision. Now you have to take the practical decision. Practical conclusion. Tell me. Come on.
Don't use oil more than 15%.
Not recommend.
Don't use or recommend the cooking oil. It is not as per the spec. Isn't it? You think that this specification is very good for your health, but there is too much variation. Can you see that? Since there is too much variation, the fat content may not be 15% always, and that doubt is more than 5%. Whenever that possibility is more than 5%, we should not proceed with the what do you call the null. So we reject the null. Clear? What is the permissible risk is 5%. So whenever the risk is less than 5%, okay, you believe the company and do it, because some amount of risk you have to take. We just go to office by motorbike. We know there is a risk involved riding a motorbike, isn't it? But we still use it. We know certain risk is okay, permissible. We can't, be completely risk-free. So here in hypothesis testing, the rule is 5% risk is okay. What is this risk? Alpha risk. Alpha risk is type 1 error. Clear, all of you?
Yeah.
So now, let us take another scenario. Similarly, cooking oil A compared against cooking oil B. That will be 2 sample t-test. I am showing you the same Excel file again. Look here, laboratory turnaround time. How many laboratories are here? 4 laboratories. Let's say you are the chief of the hospital. There are 4 laboratories you maintain, or you are the chief of the particular, pharmaceutical industry. And within your industry, you have 4 laboratories performing the same diagnosis. Some test is getting performed. So same test is getting performed means all the 4 laboratories should consume the same time only. Yes or no?
Yes.
But maintaining exactly same is difficult. All of you are attending the training program, same training program, and same question paper. Does it mean you all will get same mark, exact same mark?
No.
Some variation is okay. But if the variation is significantly different, let's say your score is below 60, we are going to deny the certificate. So significance we are trying to understand. If somebody is performing significantly different from what has been planned, we need to understand that. So out of the 4 laboratory, is there any laboratory performing significantly better or significantly, in a poor manner? That's our interest. Now, what is the test you can do now? 4 laboratory, all are measurable data turnaround time. So it leads to ANOVA. So just copy this data. RK has given you a beautiful template. You can use that. I am now showing you how can you do it in Minitab. So whichever is convenient. Some people might even feel, the manual calculation is better, and that is also available, right? You can refer RK's template. Formulas are available. Now I just copy pasted all the data in Minitab. Now the same way you can type here also on data type. The response variable is turnaround time, continuous. Decision making statistics is average. So all of these conforms ANOVA. So stat ANOVA, one-way ANOVA. Why do I call it one-way ANOVA? There is only one factor
Yes, sir,
which
there
I
is
am
a one
studying. What is that factor? What is that factor?
Turnaround time.
This is one
Turnaround
about
time.
only
Transaction time is the response variable. What is the
Transaction time
factor
is
you are studying? The laboratory. There are
laboratory.
4 types of laboratory. Factor is the lab. Levels, 4 levels. You understand? Factor is laboratory.
Laboratories.
I have 4 types of laboratory. I want to know any one of the laboratory is, significantly better or not.
Yes.
So the
Yes.
factor under study is laboratory. And the response variable is,
Transaction time.
Transaction time.
that is why you see, look at the words here, response, they're asking. Which is response, which is factor. Now, in our case, response data are in separate column. Because we have 4 column, column 1, column 2, column 3, column 4. So you click here. Now select all the 4. Click and select. Now you go to option. Now you must, for performing ANOVA, one of the condition is assume equal variance. Assume equal variance. Like for joining master black belt, you should be a black belt. Similarly, for performing ANOVA, variances must be equal. Now confidence level 95%. Two-sided, two-tail. Let it be two-tail. Okay. One more, okay. Now we performed ANOVA. Results have come. ANOVA table has come. One interval plot also come. What is this interval? Can somebody tell me what is this interval? Can you see here? What is this?
95% confidence interval.
95% confidence interval. The blue color dot is the average turnaround time for laboratory 1. Same for laboratory 2, laboratory 3, laboratory 4. The line here in the I section, the horizontal line is the upper confidence limit. This line is the lower confidence limit. To locate the upper confidence limit, you have to use standard error. To find out the upper confidence limit, you must use standard error. Right? So that's the purpose. Now that you understood the purpose of standard error, we can again, slowly understand everything about it. And now you see here, do you understand anything by looking at this interval plot? Is there any laboratory consuming more time, any laboratory consuming less time? Are you not able to take a decision?
Laboratory
3.
4 is taking less time.
Laboratory
3
4
is
is
more.
taking less time and laboratory 3 is taking more time.
More time.
And between 1 and 2, you are not able to appreciate the
Calculate.
difference. Why? If the statistics states, see here, if there is a overlapping happens, you will not be able to take a decision. Here, there is no overlapping at all. It is distinctly above. This is distinctly below. The indirect way of understanding this information is p-value. Whenever p-value is less than 0.05, there is no overlapping. So take a decision. Whenever p-value is more than 0.05, overlapping will happen in your confidence interval. When overlapping happens, that overlapping area is the additional risk. How much risk is permissible? 5%. But additional risk is also happening. So you better avoid rejecting the null in that scenario. Don't take any decision. Tell your people that this, at this stage we cannot decide. That means you simply agree that they are equal. But now in this case, you have to take a decision. And now let us go to the ANOVA table. You see here, we come to ANOVA table. We come to ANOVA table. Every information is available, factor, level, etc. All right. And now see here, this is called ANOVA table. As far as the factor is concerned, factor is the laboratory. What is the associated p-value? 0. Actually, it is not 0. It is close to 0. Minitab has rounded it. It has got some limitation. It cannot be 0. It is some value. But what we want is, we want to understand whether it is less than 0.05 or not. It is less than 0.05.
yes.
So you can just, type something here. So p-value less than 0.05. And so what is our procedure? We reject the null. Reject the null means, what does it mean? That are not equal. That are not equal, isn't it? That means use the data and make for decision making. Use the data for decision making. That means the lab number 3 will be penalized for consuming more time. And lab number 4 will be
Continue.
rewarded. Clear, all of you? Laboratory 3 is the lab that is consuming lesser time, and 4 is consuming more time. This is the practical conclusion. But this decision you are taking with 95% confidence, which means again 5% risk is there in your decision. You need to accept that.
Yes.
Why are we always saying, still 5% risk is there, 5% risk is there? Our study is limited. You see here how much data we collected. How much data we collected? $120 data, isn't it?
Yes, yes. Exovic is
With the kind of data, with the kind of statistics, with the kind of variances, this is the limitation. Please note, while performing ANOVA, one important condition is variances should be equal. You can test this also. If you want to test this, that is called test for equal variance. This is called test for equal variance. Now, what is your null? H naught. Variance 1 equal to variance 2 equal to variance 3 equal to variance 4. What is your alternate? Unequal. Variance are unequal. And now let's do that.
Hi, Nana.
Stat. ANOVA. Can you see test for equal variance? Stat. ANOVA. Test for equal variance. Description. Determine whether the variance of the standard variance or the standard deviation. Because variance and standard deviation, there is a relationship. When I square the standard deviation, it gives variance. For 2 or more groups differ. So the response data in one column. Do you have response data in one column or separate column? Separate column. Where is your data? Here is your data. Option 95%. Use the test based on normal distribution. Now Minitab is asking you, are your data normally distributed? You can either assume or you can perform a test for that also. It is always a good idea to perform the test for everything. So assume, okay, and again okay. Now the report has come. Bartlett test, p-value. The name of the test is Bartlett. How much is the p-value?
0.107.
0.10.
Greater than 0.05.
It is greater than 0.05. So under this scenario, can you reject null?
Yes.
You can't reject null.
We can't.
So that
Because
means
of
what?
it is-
Variances are variance are equal or unequal?
unequal.
Equal. If you can't reject a null, you accept the null. That's the reason why we gave tick mark. Variance are equal. Can we test normality now? Can you test normality?
Yes.
Yeah. And normality test can be done in 2 ways. One is there are 2 types of tools available to test normality. First tool is your eye. Right? You can use the tool known as histogram. Plot a histogram and verify for yourself. You know normality means bell curve, isn't it?
Yes.
And those of you who have got a problem with your eye, you can go for hypothesis test. The second tool. What is that second tool? That's known as Anderson-Darling normality test. There are different tests available, right? Any 1 or 2 you should know. So now first let me plot a histogram and let me try to use your eyes. So graph, histogram. Okay, maybe to help you, I'll use with fit. Okay, and now all the 4 cases I select and then I give okay. Now one by one you can read. The first cow, bell cow, is it looking like a bell? Come on, use your eye power and tell me, is it a bell?
Yes.
Yes, sir.
Yes.
So this
Yes.
is normal. The next one, is it looking like a bell? The second one,
Yes.
yes, right?
Yes.
You're correct. It's approximately normal. The laboratory 2, is it normal?
Normal.
Normal. Now we are
Mm,
using
normal.
our own knowledge, isn't it? We are not using any.
Normal. Normal.
This is also normal. And now all of you got a wonderful eye power now. You are able to recognize normality. So the alternate method, stat basics, 1 minute. Yeah, basic stat normality test. Variable, laboratory 1, Anderson Darling. I give okay. Look at the p-value. P-value is how much?
0.5.
P-value is how much here?
0.5.
0.5. Now, how to decide? For normality test, what is your null?
एक जो आपके फोन में आईफोन में
0.05.
Data.
Even theorem pardon.
Please note, null hypothesis is statement of normality. We already told you statement of equality, statement of innocence. Now one more definition. Null is statement of normality. The abnormality should appear in your alternate. The normality should appear in your null. So what is the alternate?
Data is non-normal.
Data is non-normal. And now you seen that p-value is equal to how much? 0.532 or something. Now what is your p-value? P-value is less than 0.05 or more than 0.05?
Less.
More than 0.05. So fail to reject null. Fail to reject null means you are not able to prove that your data is non-normal. If you cannot prove data is non-normal, what is it then? Normal. Isn't it? You are not able to prove that data is not normal. You are not able to reject the null. You are not able to reject the null. That's what. You are not able to reject the null. So we end up accepting the null. That means our data is normal. So you have now learned several hypothesis testing. Clear? Whether you use Minitab or you use the Excel template provided by RK, or you just go with the theoretical formulas and do everything manually, it's up to you. Depending on the scenario, you can choose it. But ultimately, the decision is based on p-value. So,
Sir,
yes.
Sir, one question. This when we're making ANOVA, it shows degree of freedom and the error. The error shows us number of data. How much data we're taking, it shows us error. It
Sir,
shows
can I
in this.
come?
But
Yes, please.
Please note, I'll show you a template and then tell you how it is calculated.
No, sir. I can orally give him the no. Calculation is one thing. Yes, you can show. I'll tell you why error column is appearing. Am I right?
Yes.
See,
what
you are
error?
studying your response variable with respect to certain factors, and factors can be limited to one, can be more than one also. But you are studying only one factor. What about other factors? Other factors you have not included. So those factors will also influence your Y. Yes or no? I am only studying, the teaching capability of the faculty in your performance in the exam. But there are other factors which can influence your performance in the exam. Your time availability, your own commitment to learn something new, the environment under which you are sitting right now, Those factors and all I have not included, isn't it? They will also affect your performance. If I miss out on certain factors, those effect I will not be able to account properly. So that will appear as an error. Please note. In ANOVA table, error column is appearing. That is indicating that you have not accounted for the effect of certain factors. Maybe some reason. The factors are uncontrollable, so you have not included. Or the effect is minimum, so you have not included. But that is error. Clear, all of you? What is the other question you asked? You are on mute.
This question only.
This question only. So I have answered. If you want to understand some calculations, yes, RK can show you formula. But maybe it is better you look at the formulas at the next level, not now.
Yes.
I suggest everyone not to dive deeper right at the first stage. That's why we have the hierarchy. Unless and until you are an yellow belt, we cannot talk to you at the next level. Unless and until you are a black belt, we cannot talk at the next level. Unless and until you are a black belt, we cannot talk at the next advanced level. We can talk, but definitely it will be an overdose. And that will definitely produce adverse and negative effect only and not positive effect. So that's the thing. So any other questions in similar line? Anybody? So how much confident all of you with respect to hypothesis testing, we want to know. This time RK has spent a lot of time in educating all of you on hypothesis testing. Let me do a quick survey. You can put it in the chat box or on a 10-point scale. Let us know how confident you are. Put your score in the chat box, a little survey. Are you feeling 10 out of 10 now? Or are you feeling 9 out of 10? Or you are feeling 8 out of 10? Are you still feeling low, below 5? Let me see. Come on, this is a discrete study, right? We are not measuring accurately by conducting a test or something. We are just going with a little inaccurate way. That's the limitation of using discrete data. Confidence, 7 out of 10.
Whoever is putting more than 9 will get my templates, more templates.
Now the decision will get biased now. So don't give any room for biased way of data generation. But all of you should participate. Yeah, I see many people, this is a story every time. Every time people come with a lot of enthusiasm to study. But when we teach them more, actually that is actually pulling their interest down. We don't see people interest going up when we teach more. That's why I stop RK many times. Don't go, don't proceed. He can take you and completely sink you, inside the sea. But the point is, and definitely you will swim. 6 out of 10. How many people responded? That is my concern now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 people. Not bad. Around 60%. What, sir? You are taking some stick.
Yeah.
He's ready to beat us.
Do some content from the slides, and then we will discuss to understand the tool in a better manner. So please confirm. Can you see my screen?
Yes.
Yes.
Yes, sir.
Just a minute. Let me check recording. Yeah, recording is also going on. So we are going to understand about correlation and regression. And the beginning point for correlation regression is your scatter diagram. You all know scatter diagram, right? So scatter diagram is one of the 7 QC tool, quality control tool. You can use the scatter diagram, or you can conduct the correlation analysis, regression analysis, when both your X and Y are continuous in nature. Both your X and Y. X is the input factor, Y are the output factor. But in regression analysis, we call X factor as predictor variable and Y factor as response variable. If both your X and Y are continuous, that's the time, then only you can plot a scatter diagram. And from scatter, we move on to correlation when we move on to regression, right? So that's how it is. So let's try to understand. And now look at my diagram. Look at my screen. And you are seeing a scatter diagram here. Look at the x-axis, predictor variable. Y-axis, response variable. I keep on increasing my x. What happens to the y? Y also increasing. If I plot the y values, I can even understand the pattern. What is the pattern here?
Linear.
Pattern is a straight line. Is it a perfect line? It's a perfect line.
It's a perfect line, sir.
It's a perfect line. And I also see that increasing the x is increasing the y. So relationship is positive as well as perfect. Clear, all of you? Perfect positive correlation. What is it? Just by looking at the scatter, I could understand the relationship is perfect positive correlation. We use the word correlation whenever we see linearity. Now look at this graph, second graph. What is the difference here? Pattern is perfect linear, but direction of relationship is negative.
Negative side.
The first one is perfect positive, second one is perfect negative. The third one, I keep on changing the x, but I am not able to see any pattern or any kind of trend in the y value. Now I conclude that there is no correlation. All of you understand here? So it is basically the diagram what you see on my screen is nothing but the scatter diagram. So basically the scatter diagram is letting you to understand the direction of relationship and the pattern of relationship. And now I am showing you another scatter diagram, X and Y. Now tell me what kind of relationship it is, all of you. Is it positive?
Yeah, positive.
Is it perfect?
Near
Positive?
perfect.
Agreed?
sir.
Perfect.
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 See,
Yes.
see, perfect means you have seen, a perfect straight line. Are you seeing a perfect straight line in this
Straight
case?
diagonally.
It's not perfect.
Not perfect.
It's not perfect, but it looks strong. So if you can't read directly with your eye, then a formula is developed to overcome the difficulty. See here, this is known as correlation coefficient, Pearson correlation coefficient. It just makes use of some statistics. What is n here? Number of data, x bar y bar sx, sy, standard deviation. With all of these values, you can find out r. The r is designed in a way that it will vary from 0 to 1 on the positive side as well as on the negative side. The maximum 1, if it reaches the maximum, that's the time you will see perfect relationship. Or whenever perfect relationship happens, r will become 0. Sorry, r will become 1. Whenever there is no relationship, r will become 0. That manner only formula is designed. Statistics is like that. Now, 0 to plus 1 is positive correlation. 0 to minus 1 is negative correlation. Up to 0.4, we call it weak. 0.4 to 0.7, we call it moderate. 0.7 to 1, we call it strong. Exactly 1 means we call it perfect. Now we understand this is positive. Why positive? Increasing the x is increasing the y.
Yes.
And this is not perfect, but the points appear close to the line. The point appear close to the line. So that means there is some error, but error is minimal. Now you can say it is strong positive correlation. Now we don't say perfect, but we say strong. Clear?
Yes. Yes.
Yeah. If you want to be doubly sure, use this formula and calculate the R value. R is 0.97. It is definitely above 0.7.
Yes.
If you have this table in your hand, you can even say the relationship is very strong positive. That is a better idea. Isn't it? So,
Yes. Yes.
so when you are writing the report, when you are making conclusion, all of this, terminology will help you. When to say strong relationship, when to say weak relationship, when to say positive, when to say negative, all happens with the help of this R value. And now, Look at the scatter diagram and tell me what kind of relationship you are seeing here.
Strong. It's positive correlation. Strong.
It's positive
Strong
and
positive,
it's
strong
positive.
positive,
Yes.
correct. The second one,
Strong negative.
It's strong negative.
strong positive, strong negative.
Negative.
See here, the diagram is also supplemented with R value. You can see here. Now this one, what is the relationship you are seeing here?
Positive.
It's
Weekend.
Three undu.
It is weak.
Positive, weak.
or weak.
This is negative weak. Weak
Negative.
positive, weak
It's
positive,
strain
weak
also
negative.
down. It's strain
Yeah,
down.
side
Downside line.
weak negative. Very good. Now, oh God, 1 minute. Once again, I have to just charge. Okay. And now tell me,
No relation, sir.
no
No
correlation,
relationship.
No correlation.
No one.
no relationship. No correlation, no relationship. Now, first case, no correlation, no linear pattern, and I don't see any other relationship also. I am also saying no
No
relationship.
relation.
But here in the last one, can you see a kind of graph here?
Yes, sir.
Yeah.
It's negative and
What is
positive
that?
both. in it.
Positive and negative both.
This
Both
is not
relation.
logarithmic. This is parabolic. This is
Yes.
parabolic or quadratic. So
Quadratic, yes.
here I am saying no correlation because there is no linearity. This is called non-linearity. You are seeing a curve. Can you see here?
Curve,
Whenever
yes.
you see this is called a non-linear relationship, and particularly this is known as parabolic relationship. Sometimes we call it as quadratic relationship. All right, now that you know something. So now imagine we are doing a small study experiment. You know what is the experiment? We are studying the influence of calorie consumption on the weight gain. Now tell me which is y variable, which is x variable here, or which
Weight
is the
is
input?
X.
Calorie consumed is X and
X.
Y is
Weight gain is the y. So how the experiment is done, I will tell you. See here, a person is advised to consume 1500 calories for a specific period of time. And the influence on the weight gain is observed over a period, let's say for a 1 week time. Throughout the week, his weight remains stable. That means weight gain is 0. Do you understand, all of you?
Yes.
Now the calorie consumption is increased. Now every day he has to consume 2300 calories. Now how much weight gain we have observed over a study period? 200 grams. Now the reading is done. So every reading is 1 week effort. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, near about 14 weeks. The experiment is done. Now we are going to understand the relationship of the calorie consumption with respect to the weight gain for a particular individual. You cannot use this data for other individuals, isn't it? This is applicable because the sample can only represent its population. The population is that individual. So all this study and the information we derive, we'll use it only for that individual. So now, for this data, I want you to calculate R value. Look at the R value, 0.97. What do you understand? Strong linear relationship, very strong linear relationship. And over and above, I want you to calculate R square. R square is 0.97 multiplied by 0.97. How much it is? 0.94. This 0.94, the R 0.97 is telling me something. What is that? Relationship is positive. And moreover, relationship is linear. Now, this is telling me something different. 94% of the variation we observed in the y variable is explained by the variation we have made in the x variable. Listen to my statement very carefully. 94% of the variation observed in the y variable can be explained by the variations we have made in the x variable. That means this x factor is many factors can influence the y. But this factor alone is influencing to the extent of 94%. Am I correct? Do you understand now? What is the influence of this particular factor on the y variable? 94%. When you are conducting the study, only this factor alone is responsible for the weight gain or weight loss, whatever you observe. Because all other factors are in perfect control. All other factors are in perfect control. That means during your study period of 14 weeks, what is the factor that is, really fluctuating? Only the calories is fluctuating. And that is now appearing in the form of R square. So R square is the single factor that is responsible for the variation in the y variable as per this particular data. How many of you understand this? All of you understand this? So the influence of the X factor is 94%. Imagine whenever you take decision in your house, your decision is influenced by all the family members. Am I right? Your kids can influence certain decision. Your wife can influence certain decision. You yourself will have some influence on your decision. Now you have to assign a percentage. Most of the decisions are influenced by the lady in the family. Am I correct? If your wife says now, that is final. You cannot change for that, isn't it? That means the influence is very high. The similar line, we are studying the influence of the calories on the weight gain. And what do we understand? The influence is how much? 94%. So how much is left over then? Only 6%. According to the variation we are seeing in our data, 94% of the reason for the variation is this factor. That means this is the only factor that is currently influencing your Y. If at all you want to make any changes in your Y, you just work with this and your purpose will be done. You don't have to worry about other factors because other factors are not playing. You studied only this factor, isn't it? So, how much influence a factor has got while doing a project, you can understand with the help of this tool. If the percentage is more than 80%, you can understand that factor is the single root cause. Isn't it? If that percentage is, let's say, only 30%, then you need to understand that is not the only root cause, that is one of the root cause. Do you understand my language, all of you? So
Yeah.
R square, if it is more than 80%, the factor sufficiency is ensured. Factor sufficiency is ensured. Now the R is known as Pearson correlation coefficient. However, R square is known as coefficient of determination. Make it a point. Now, I want to create a mathematical model. I want to create a mathematical model of my data. What is the mathematical model I should go for? In the scatter diagram, I understood that the relationship is linear. Am I correct or not? So I will go for a linear relationship. And then I will frame a mathematical equation. The mathematical equation describing the relationship between X and Y is known as regression equation. And the purpose is that a regression also can indicate direction of relationship, can indicate size of the relationship, can indicate statistical significance because it will give you a p-value, and regression can be used as a prediction model. And how can we use regression as a prediction model? And the principle of least, it uses a method known as principle of least square, and all that we will try to understand. And see here, the first case, if your scatter diagram is going like this, the relationship is linear. If it is going like this, the relationship is quadratic. If it is going up and down, the relationship is cubic. And how the mathematical equation will look like for a linear relationship? Look at the mathematical equation, y equal to ax plus b. You might have studied y equal to mx plus c. Am I right? The m is replaced by a, c is replaced by b. How many x factors are here in the first equation?
1.
How many
One.
x? Only one. So this is known as simple linear regression. But in the second equation, you have two x factor.
Yes.
This is now multiple linear regression. and order is 1. Order 1 means there are no x square involved here. You see, you don't see any x square. You see only x power 1. But for quadratic, the equation will be like this: y equal to ax square plus bx plus c. Now, can you see x square? So order is 2. Now for cubic, what is the order? 3. Now you know different regression models. Regression with the model order 1, model order 2, model order 3. Model order 1 means linear. Model order 2 means quadratic. Model order 3 means cubic. See, you have to fit your data with the proper model so that you can judge the quality of the work you are doing. Once the regression equation is arrived, regression equation will speak the quality of work you have done. And we'll see that. See here, for the same problem, x-axis is calories, y-axis is weight gain. We've drawn the scatter diagram. You can see the regression equation here. The regression equation is nothing but y equal to mx plus c. Now, what is m here? Can somebody tell me what is m here?
Slope.
Slope. Slope means angle your line is making with the x-axis. This is the angle. Will you be able to measure this angle?
Yes. Degree.
How?
By degree.
How can you measure? How can you measure?
By degree.
Yeah, you know the geometry box. All of you might have used in school, right? That instrument, that scale is known as protractor, right? You take that protractor and then measure this angle. Once this angle is measured, simply go for tangent of the angle.
10, yes. 10 theta,
Now
yes.
that will give you this 0.4. You see here.
Yes, yes.
This is one method. Another method, you draw a horizontal, draw a vertical. The
Yes.
vertical line length is del y. Horizontal line length is del x. Now you go for del y divided by del x. What is del y? Del y is the opposite side in this triangle. In this triangle also angle will be same theta, isn't it?
Yes.
Opposite side by adjacent side is nothing but tan theta.
10 theta, yes.
So nothing but m is tan theta. See, I'm only, the softwares will do everything, but I want you to understand this, right? So the 0.4631 is now calculated by yourself. Now the line, you drag it downwards. When you drag it downwards, it is crossing your y-axis at this point. Can you see that? And this point is seen below origin. Am I right?
It will come negative.
Very good. That's negative values here. Once you plot a scatter diagram, you yourself can write this equation. That is my point here. Am I right?
Yes.
You don't have to rely on some software. But if you have got a software, some tool working for you, please use it. But then you should know the logic. All right. So
Yes.
now regression can indicate the direction. If you want to understand the direction of relationship, see this number 0.4631. This is known as regression coefficient. This is known as regression coefficient. Tell me, is this coefficient positive or negative?
Positive.
Positive.
So relationship is positive.
Yes.
Scatter diagram also helped you. R value also helped you. Now what is this helping you now? Regression coefficient. Regression coefficient is telling me that this particular factor, calorie consumption, is positively related. So direction of relationship is understood. That is why I have written here. Regression can indicate the direction, can also indicate the size of relationship. What is size of relationship? If I change x by a certain amount, how much amount y will change? Why should you need this information? What is your project? Your project is to optimize your y. Am I right?
Yes, right.
For optimizing the y, you must optimize the x. But how much you should optimize? Now regression is going to tell you an important information. Please note here. The 0.4631 is telling me that if I increase the x by 1 unit, y will increase by 0.4631 unit on an average. Is this statement easy to understand, all of you?
Yes.
So the sign of the coefficient indicate the direction, and the magnitude of the coefficient represents the change in y you can expect while changing the x. Now tell me, if I want 400 grams weight gain, how many calories I should consume extra?
400 into 0.4.
Every 1 calorie when I consume extra, I gain 0.4 grams. That is the
400
meaning,
into-
isn't it?
Yeah. So 400
I
meaning-
need 400 grams. So maybe 1000 calories extra if I consume, then probably no, in that period of study itself, I will gain 400 grams approximately. Clear? So that's the idea. So this can be better understood when the example becomes much simpler, right? See here, look at the equation, look at the scatter diagram here. Look at the equation. What is the equation? Y equal to x. Now tell me, what is the correlation coefficient here? How much is the coefficient? I told you correlation coefficient, right? In the previous example, the correlation coefficient is 0.4. Now, what is the correlation coefficient?
1.
I mean,
0.4.
regression coefficient, 1. Regression coefficient is 1. What is that? 1 is positive or negative?
Positive.
Positive.
So, positive relationship. Now, what is this 1 is indicating? When I increase x by 1 unit,
Y also.
Probability.
y also increase by 1 unit. You see here, increase x by 1 unit, y increase by 1 unit. Increase x by 1 more unit, y increase by 1 more unit. Increase x by 1 more unit, y increases 1 more unit. Perfect. Whenever the relationship is perfect, and your interpretation will also be perfect. So the challenge is, in order to take the right action, you should be able to find out the perfect relationship that may exist between your x and y. That is called regression equation, right? The quality of regression can tell you whether all your actions can yield the expected the expected results or not. Now look here, another thing, another equation here. I increase x by 1 unit. How many unit y is increasing?
2.
That means what will be the equation? What will be this equation now? Y equal to
2x.
2x.
1 for 2x.
Y equal to 2x. Now the m is 2. M is known as regression coefficient. Now, for this particular thing, the regression analysis, we have developed with the help of, this is Minitab report. I'll show it in Minitab also. See here, the R square has come. How much is the R square? 93. You remember, we also did it manually. R equal to 0.97 and then, it is 94. That means R square 93% means this factor has got an influence of 94% on your y. That means this is the single root cause. You can conclude. Now you just go through the recap points and tell me, are you comfortable with all the recap points? Or anything you are not able to understand, let me know. Everything is clear?
So one point you told about if r square is more than 80%, what it signifies exactly? I missed that point.
Yeah. If R square is more than 80%, that means factor sufficiency is ensured. If you develop a regression model or regression equation, see any regression model will come with R square. You see here. Can you see R square? That is
Okay.
known as model summary. The moment you see R square more than 80%, you can understand you have included all significant factor. If it is close to 100%, it is much better. But minimum requirement is 80%. If R square is not 80%, that means you have not included some significant factors.
So those are nothing but our inputs to get this outcome.
Nothing but, nothing but the input factors. The input factors needed to optimize your Y. Now, how many input factors are needed? Only one. Because with one input itself, what is your R square? 94%.
93.
That's the point. And here are the recap points. All right. So now let us see how we can do this, in Minitab. So first, let me pick up the same data. So I'm just sharing my Excel file first. And now this particular problem is calorie consumption, right? Now here, you see X and Y. Look here how much effort is required to find out the R value. All the calculation I have indicated here. If you want, you all can, go through that to understand. Now I'm just copying this X and Y. Control C. I want to take this to Minitab. So I'm sharing Minitab screen now. You can see Minitab. Now I'm just pasting that information here in column 11 and 12. You can see column 11 and 12. Yeah. And now first, let me show you correlation. See here, let me show you scatter diagram. Graph, scatter plot. For plotting the scatter plot, you have two options, with the regression or without also. Let me choose with the regression. Okay. And now your Y variable is column 11, X variable is column 12. Now you give okay. Can you see the scatter diagram, all of you? Right? So this is a kind of first level understanding, plotting a scatter diagram and understanding. So what kind of relationship you are observing here? Linear. Positive as well as linear. Now, so I am going for the correlation, basic stat, and now this is correlation. Correlation between X and Y. So I have X and Y. I select both. I'm giving okay. Now this correlation is giving me how much? 0.97. Isn't it? With the help of 0.97, you can convert into R square, which will be 0.94. Now let us proceed with the regression. Stat, regression, fitted line plot, and now your Y. Your Y is, yes. Oh, here. Y is weight gain. Your X is
Input calories.
calorie consumption. Now, which model will be best suiting for you? Linear, quadratic, or cubic? Which one will be best to suit? You want to go with linear or you want to go with cubic?
Linear.
Linear. Well, how are you telling? Because just now you have seen it in your scatter diagram, isn't it? Just now we have seen in the scatter diagram. That's how you make a choice. And you give okay. And now everything is done by Minitab. You see here, all the values are done. And now R square is also healthier.
If I put cubic, what happens? Cubic or
Come again. If you take?
Stuff linear. If I put cubic.
If you take cubic, sometimes it may not suit. Sometimes it might suit. Whether it is suiting or not, how do you understand? By looking at the R square. By looking at the S. We want minimum S. We want maximum R square. Since you asked, we can try, nothing wrong. So regression, fitted line plot. And now I am choosing cubic. I am giving okay. Now what happens to your R square?
97.7.
Improved or reduced?
It's improved. Sir.
Improved. So that means your thinking is correct. And look at the S. S decreased or increased?
Decreased.
That is also supporting. So better go with this. You understand? So you are mathematically you are modeling the problem. Whatever the data you convert into a mathematical equation. You see here, the equation is here. And you are able to arrive on a perfect regression equation that is indicated by the R square. That means all the actions you are taking are really in the correct direction. You are thinking in the right direction. That's why the regression is coming with a better R square. Otherwise, what happened? It might the R square might be sometimes very, very low. Let us see a case with very poor R square. Maybe I am bringing another set of data here. Wait. So I copied the data. Let me show you now. See here. Now I am pasting another set of data. What is that data reading? Column 14 is hydrogen content. Column 15 is porosity. All of you, do you know what is porosity? Because normally porosity is a problem, happens in metal casting. Right? There will be some pores inside the casting produced. So now let me go for a regression model straight away. Stat, regression, fitted line plot. Now, what is my y variable? Porosity. My x variable is hydrogen content. With this only assumption, please note, because we have not studied scatter and other things. So I am assuming linear here. I am giving OK. And now the model is developed. Now look at the model, look at the R square, and please comment on it. All of you. What is R square you are seeing?
The R square value is
39.
39.
What does it mean? 39% means what?
It is the inputs are, it is less than 80% and inputs are not sufficient.
The significant factors are many, but you have studied only hydrogen content. You thought that hydrogen content is influencing the porosity. So you studied only that. And you collected data and now you modeled it. Now you realize it has an influence of only how much?
39%.
39%.
So
That means there are some other factors.
some other
also
contributors are involved.
Some other factors are also contributing to the same problem, which you are not included in your study. So now you must necessarily include one more column. What is that? Another factor. I don't know. You go to your fishbone diagram. Find out which can be the next contributing factor. That factor should come here. You should collect data about that factor also. You must collect data, isn't it? Whatever it is, you collect data, include it in your model. See whether your R square is going up or not. But prior to that, you can study the significance of the factor separately. That's why we have taught you hypothesis testing. Do you remember? Every factor you study separately. And if whatever factor which is getting validated as a significant factor, you bring it for regression and then plot the regression model and look at the R square. If you see R square more than 80%, that means you are good to take action. Do you understand, all of you? All of you, do you understand, or are you getting confused? You're not getting confused, right?
Understand.
Yeah. If R square is more than 80%, your analysis is over. You can move on to improve phase. Here, what is improve phase? Solution. You take action for every factor which is there in your regression model. And how to take action? In order to take action, you need the relationship. That relationship is also now available, isn't it? See, what do you want to achieve? You want to optimize your Y. Let's say you want to increase your Y. If you want to increase your Y, identify the factors that have a positive relationship. Increase them. Do you understand? Suppose if a factor has negative relationship and you want to increase your Y, what will you do?
It will not happen. It will not
If
happen.
you want to increase your Y, But one of the root cause is having a negative relationship. Now, how will you adjust that root cause? Will you increase or decrease?
Decrease.
Decrease the root cause.
Decrease
That's
the
all. This thinking and this knowledge is very, very important while developing solution. Now you have gained all that knowledge here in the analysis phase. Clear, all of you?
Yes.
Now I want you to use the regression in the initial stage and see. Come in this. I don't know in which sheet. I typed something maybe here. Okay, no problem. I will type it again. See here. See here. I have y variable, right? Okay, I have x variable, and I have y variable also. Let me say x is let me say the x is some factor, maybe temperature. X is temperature. Temperature, I know it will vary from 70 degrees Celsius to, let's say, some value 70, 75, 80, 85, 90, 95, and then 100, and 105, 110, 115. So the temperature is expected to vary from 70 degrees Celsius to 120 degrees Celsius. This is how currently my process, is working. Y variable is something, let's say yield of a process or something. Let me assume some relationship here. Y equal to 2 times the X factor plus a constant. I'm saying that no constant. Let's say 35. Now I am getting Y value. See here, I have an X factor, Y factor, and with the help of the, what do you call, the regression equation, I generated the data. The same data I'm copying here. I'm taking to, see, this is only a hypothetical scenario. I'm simply generating data and taking you. Now let me go to some new worksheet. File, a new Minitab worksheet. Now I brought the X and Y here. Can you see X and Y here? Same X and Y. Now let me look at plot a scatter plot. I plot a scatter plot. Okay. Y is this. X is this. Now I am giving okay. What is the relationship? Tell me. What is the relationship?
Linear, positive,
Linear, positive. Is it perfect?
strong.
Perfect or not?
Linear positive. Yes. Perfect. Perfect.
Perfect. You can see the line also. Y and X. Yeah, you can see a perfect. Now let us see that equation. Stat, regression. Okay, fitted line plot. Y variable is this one. X variable is this one. Oh, sorry. X variable is this one. And linear is select. What is this? X variable is this one. Linear is selected. I am giving okay. What is the equation?
R square 100.
No, read the equation first. Y equal to?
35 plus 2x.
Do you remember in the Excel sheet I used this formula only?
2x plus 3.
So based on the date, based on the equation, I generated data. Now based on the data, I do the reverse method, isn't it? I do the reverse method. Now I generated the equation. Since it is a perfect fitting, how much is the R square I'm getting?
100.
100%. Look at the S value.
0.
Ultimate scenario. But when you do an experiment, from the experiment you generate the regression, your R square, there will be some problems, isn't it? Always when you do an experiment, there is a chance of experimental error. Am I right?
Yes, sir.
Sometimes you may miss out certain factor. Three factor might be playing, but you might have included only 2. Or 2 factor might be playing, you might have included only 1. All these mistakes you might do. As a result, and moreover, linear model, you might choose a quadratic model. And for quadratic model, you might choose cubic model. All these mistakes, if you do, your R square will get affected. Agreed?
Yes.
Agree.
So whether you are thinking correctly or not, the regression report will tell you what should be your aim. Your aim is higher R square and lower S value.
Value.
S is an indication of the error in your regression model. Lesser the error and greater the model, better will be your decisions and better will be your actions. All of you understand?
Yes.
Now, any questions? Please feel free to ask.
So normally,
questions?
if it is R square is more than 90 and above, so which we consider whatever we took a solution is it's a right. If I want to further
if R
increase
square
90,
is-
if further I want to increase 90, I have to take a further, the possible root causes. I mean, the potential root causes, and I have to work on it. That's what you told.
Suppose R square is 90%, but you still want to improve, then you must consider either adding additional factors, or you must consider changing the model, or you must consider bringing a high quality data. See, that is why, data quality is very, very important. Because see, all the AI tools, artificial intelligence tools, all of them work based on regression.
Sir,
You
can I
are
come?
talking about driverless car, isn't it?
Can I come, sir?
Yes, sir, please.
Please note, you are having R squared of 0.8, right? So what do? You add a factor. You add another factor. Am I right? So now you get 0.9, right? Now the question is, will you be satisfied or will you not be satisfied? Tell me.
Because of 0.8 to 0.8.
No, no, you cannot be satisfied because any factor you add, any redundant factor, R squared will increase because you have used some damn factor which is not at all relevant. The R squared has gone up to 0.9. Therefore, you have to see R square adjusted. If the R square adjusted also has increased, then you can be satisfied. If the R squared has gone to 0.9, but R square adjusted has gone down, then the factor that you have considered is redundant. Understood?
So what sir is telling is,
the way you get that R squared is very important rather than R squared value itself.
See, these are formulas, methods, statistical method. Initially, they developed R square. See, initially, for example, the very first batch, when we conducted black belt, the quality of our training was not this level. Am I correct?
Yes.
But now the quality we maintain is definitely the best you are receiving. Continuous improvement, isn't it? So similarly, when originally the regression model was developed, they introduced the tool R square first. Later realized that have some limitation. So they introduced another R square. What is the name of the new R square? Adjusted R square.
Adjusted, okay.
Adjusted R square can correctly predict whether the factor you are adding is a significant factor or not. If you add a significant factor, it will move upwards. If you add an insignificant factor, it will not change. But your R square, which was introduced long back, that do not have that intelligence. You add any factor, it will improve. So which is the best R square out of the two? Tell me.
Adjusted.
Adjusted R square is the best one. Like CP and CPK. CPK is the best one. Same manner, R square and adjusted R square. Adjusted R square is the best one. So look at the adjusted R square. That's the point. So let us talk about one application of regression. Can you tell me one application of regression? One use case of regression analysis. Oh, 12:10 only. Today we are going ahead of the schedule. I am wondering. Normally we run out of time, but this patch, I don't know. Somehow we are going ahead of the schedule. Yeah, come on. One example, one use case. Regression analysis. Okay.
So you're talking about the any examples you want to share, right?
Any example scenario for application of regression analysis.
Sir, last match of the India and versus this the last turning point. We
Okay.
have lot of things.
Very good example. Very good that you brought cricket. Let's say leg before wicket. Bowler has bowled the ball and it has hit the batsman's pad.
Yes.
The umpire didn't give out. He said not out. Then what happened? Normally the bowling team captain can go for a review, DRS system.
Yes. Analysis.
Now in the DRS system, they replay the ball.
Yes.
When they replay the ball, the path traveled by the ball is captured by the camera, isn't it?
Yes.
That means data is captured, the real data. Data till the moment ball can hit the batsman's pad is collected.
Yes.
With that data, they generate a regression model.
Yes.
And visualize the graph.
Yes.
And now the path traveled by the ball is available.
Yes.
When that curve is available, can you extend the curve in the same manner?
No.
In the same manner, when you extend, you will be able to understand whether this ball is going to hit the stumps or not.
Yes, possible.
Yes. Okay. Yes.
That
Sure.
how are you extending? That's a prediction. You are using regression now for prediction. For prediction capability, you must have large amount of data.
Yes.
That's why the camera can collect too much data. Every second it will be capturing the position of the ball. Too many data points are available, and then every change in the what you call the X value, the ball position is recorded, and so subsequent if the ball travels further, and this will be the direction, and so the batsman is out or not. I think I have got we can.
The R square adjusted you mentioned, that is seen only in the Minitab, or is there any other tool also we get calculated that?
Yeah, that will come in Minitab, and from Excel also you can. I think you can generate regression. RK you can learn from RK.
Yeah.
Excel also can generate the regression report. Any ANOVA, if you conduct, automatically ANOVA will come with the regression equation. That will come with the model summary. The model summary will talk about the quality of the regression model. So by looking at the regression model, you can judge on the quality of work and quality of decisions you are taking. Okay.
So you are talking about one term multi-collinearity, which is there are so many factors which will be interrelated. So if it is so many factors present in it, we can take it one. Remaining.
See, please note. See the idea of R. See, all of them are formulas. Please understand. The formulas are designed, in certain manner. If I keep on adding factors, what will happen to R square? R square will keep on improving. But if I keep on adding all insignificant factor, then my R square might improve without any, proper value addition. So I'm not supposed to add insignificant factors. So that's why they made some improvement. they modified, R square to adjusted R square, number one. And number two, sometimes what happens, factors will be interrelated. For example, your age, your experience, and your salary, all of them are interrelated. But I want to understand your performance capability. Should I use your age? Should I use your salary? Or should I use your experience? Which is a good indicator of your, the performance capability? Is it the age is an indicator? Or is it your salary is an indicator?
No.
Or your experience is an indicator?
Experience.
So I will include experience as a factor in my model. I will better leave your age and salary. Because they are interrelated. More age, more will be the experience, more will be the salary. Why should I have all the three? One is enough.
Yes.
As far as the mathematical model is concerned, provided there is multicollinearity. Because multicollinearity, if it is present, that will weaken your regression coefficients.
But
will
in
be-
regression we are taking only one factor, no? X factor, Y factor. So
No,
you are
no,
talking
no,
about
no.
multi.
You can take more factor also.
Okay.
See, I have taught you only simple linear regression today.
Okay.
If but Google Map example itself, 3 factors.
Multiple.
That will be multiple linear regression, which we will be taking up
Okay.
in the next level.
Okay.
Okay. So RK sir, you have anything to share with them? I think
Yes, sir. Yes, sir. I have a lot to share
this is-
with them. I have a
today
lot to
this
share with
is
you. I have a
look
lot
quite
to share with you.
abnormal.
In fact,
We are ahead of the schedule. Rarely this happens. I don't know how it happened.
please note what all we have seen so far. Today is the second day. Today is Sunday or Saturday? Today is
Sunday.
Saturday.
And green, last day for the green bells here.
Today is Sunday, no?
Yes, sir. Sunday.
Today is Sunday. Afternoon, please, all of you keep yourself ready for giving a feedback. Right? The whatever marks you give some scale. Put some scale and then give the 4:30 onwards. We will have that feedback. And now, in order to give you good feedback, I must give you whatever you want. No. So now you ask me whatever you want. And if you don't ask me, that means I have satisfied you fully. Right? So tell me now, what is that you want now on hypothesis testing? Right. Yes. All of you, please come on video. I'll give you food for thought now. All of you, come on video. Please come on video. Yes. Thank you, Netaji. Saravanan, where are you? Venkatesan, Srinivasan, Abdul Sattar. Abdul Sattar, what happened? You were active initially, now stopped.
And all of you, do you see the mock questions in the description, WhatsApp group description?
No.
Please try those mock questions. It's there in the description. Or I will post it.
No.
Sir,
I will-
the question is MSME page only, right, sir?
Yeah, whatever
yeah,
questions
same.
you will be getting, we will be given you answers. And for more details, you can go to videos provided by Gopal Shokumar and RK later on. Yeah. Now, the first define phase, there are 3 steps. We used some tools. What are the tools we used in define phase?
Mean, medium, meridian.
Huh? Yes, very good. Yeah.
Mean,
Mean,
medium.
median. No. Define phase. We want to define the problem. That's all. In the define phase, what do we want to do? We want to define the problem. Very simple logic, no? What do we want to define? Want to define the problem. Why do you want to define the problem? We should solve. Why do you want to solve the problem? So that people will pay you salary. Simple, right? You create a problem and tell them, yeah, I want to solve this problem. Whether it is important to be solved or not, they will tell you. But for that, you will have to do some homework. And what is that homework called? Project charter. Yes or no? In the define phase,
Yes.
all we are doing is defining the problem and nothing else. Defining the problem, you have to be very carefully. I can't go and tell my wife, no, I want to go for a movie. Yes or no? Can I tell?
Yes, sir.
No, I will have to tell that I want to take you for a movie, I should tell. Yes or no?
Yes.
If I say that I want to go for a movie, will my wife permit me? No. I will say, first of all, I want to take you for a movie, good movie, and a very family movie. I will tell all these things so that she will say, hey, very good, we can go. But I have got homework for you. You go alone, come. I'll prepare dinner for you. Because I was good to her, she will be good to me. Then I'll go out and see my movie, not family movie. I want to see my movie, right? I want to see Leo, all action movie. You will have to provide the best to your management. What for they have employed you? Tell me what for they have employed you, to create problem or to solve problem?
To solve.
To solve problem. So you will have to find the problem, then only you can say that I can solve this problem. If you don't find any problem, they will see that what is that, he does not know. What is the use of him for me? Therefore, you are every year you have to do a problem. Every year you have to solve some problem for the company, then they will be happy that they need you. They must be keeping on improvement. Not that improvement means you will go from 0 to 100 like that. No. Every year there will be the new problems coming. You have to identify the new problem and then solve the problem. Modi is facing different problems, different years. Yes or no? 9 years, 9 different problems. Right? Similarly, you will have to find out the defined phase is important. Why defined phase is important? If you do not define the problem, there is no further phases. Then, after you define the problem, get the approval in the project charter. What is the next step? Appropriate gauge, measure phase. After using the gauge and measuring the gap means what is wanted, what is actual, current, right? You have to go for finding the causes. How do you find the causes? Tell me, how do you find the causes?
Brainstorming and YY analysis.
Very good. Brainstorming and
YY analysis.
Data analysis.
Sorry. Brainstorming analysis.
Brainstorming analysis.
Fishbone analysis.
Brainstorming.
Fishbone.
Huh? Yes. Important thing you forget, yeah. Please note. You are fish out of water now. I have given you a hint. What is that? What is that you do? Use.
Fishbone chart.
Fishbone diagram. Very good. Use fishbone diagram to identify. Then you have to find out which are all significant. That is called potential causes, right? Whatever you may give different name. I will say significant causes. How do you find out the significant causes? Yesterday, I think it out. Not yesterday, last class. I forgot. Today.
Sir, control chart I have to do.
Control chart, data chart.
Impact control matrix, right? Okay. Right. That is cause and effect matrix, you can call it. Right. Then what you have to do? You have to validate those. For validating those, what will you do? What will you do for validating? Hey, what we are doing, we are doing at present. What is it we have to do? Validating the significance, what should we do? This is where I win over you. After teaching the entire thing, I'll ask you a simple question. You will bring
hypothesis testing, sir.
Yes, that is what we are doing today.
Hypothesis testing with the alternative and
I gave the hint also. We are doing. Tell me the answer. Yes. Okay. This hypothesis testing is done only for this purpose, right? Whether it is significant or not, validating. Then only we will go for regression. Then only we will go for regression. Regression will go for which factors? With these factors. Hi, Saurabh. Fine. So, for validating, what we do? We have to conduct a test. Yes or no? For conducting a test, what we should do? We should take. What should we do?
Question and
I want to find out whether you are good or bad. What should I do? I should have you. Yes or no? I should first of all have sample. I should take a sample. right? I must take a sample and do the test. Then you will see whether the p-value is low or high. What is the decision we are making on hypothesis testing? In hypothesis testing, we are taking a decision on what?
Decision on sufficiency of the factors.
Not
Correlation.
sufficiency.
Correlation of.
Sufficiency, we are doing it in regression. Sufficiency, we are doing it in regression.
Decision of what we claim.
Huh?
Decision
Whether
on
it
what
is-
we claim.
Yeah, what we claim on null hypothesis.
Null
We are taking a decision on
What we
null
claim.
hypothesis. What is null hypothesis? What is generally believed as it is. What is a claim? Claim against the null hypothesis, right? Now I will take you to sharing the screen unless Gopal should.
Yes, sir. RK, sir.
Yes.
So control chart, we have to show them, sir.
Okay.
I'll do that.
Okay.
Let me finish that.
Okay.
So another important tool we must learn prior to seeing the formality steps in improve and control is a control chart. Can you tell me what is the purpose of control chart? Anybody? What is the purpose of control chart? We are trying to understand.
So once
the
we
special
optimize,
Analyzing the things to maintain.
once we optimize the process, we have to maintain the critical parameter in
Yes.
terms of specification and tolerance, in terms of control chart, because of we have to monitor regularly.
To find the special cause.
Very good, to find the special cause. Very simple. We want to understand whether there is any abnormal behavior happening. See, sometimes what happens, some background noise is coming. Can I consider that as an abnormality? Because the design is, like you're expected to sit in a room which is noise free. And you see now it is coming. There is a special cause, right? So any abnormality, if it happens in our process, we need to understand and we need to stop it first. If we don't stop it, you know what will be the consequence? Let's say there is a lot of background noise in all your places, and we are delivering a beautiful lecture from this side. Will there be any use? Same will happen in your workplace also. If your process is not, performing normally, whatever actions you take from your side will be useless. You understand? See, you are taking a lot of actions with a good intention of seeing improvement, but nothing will materialize simply because your process is out of control. Imagine a scenario where the kids in a family is not at all obeying to the parents' advice. Now, whatever be the quality of the advice, if they are in a mood not to obey, what is the use of you giving advice? Similarly, any process, if you want to make any improvement, the primary requirement is the process should be under statistical control, or it should be free from abnormality. Whether an abnormality is present or not, we use different languages. Special cause. Special cause is something not part of the process. In a normal condition, when a process is running, that special cause is not in your design, but suddenly it is coming and then affecting your process. So whether there is a special cause exists or not, if it exists, it must be eliminated. After that only all the improvement action you need to take. So now I'm taking you to Minitab. You make the subject very simple, and let me open a file. Open worksheet. File, open worksheet. I click this once so that I can access to the sample folder, and file name is camshaft. And now you all can see the data, right? Now here, the camshaft data. First column reads length. How much data available?
Hey, Hari.
Come on, how much data available?
100.
100.
100 data. Now, the data, first of all, is so much. Okay. Now, the data is length of camshaft. Now, please tell me, length of the camshaft, is it measurable?
Yes, sir.
Yes.
That means this is continuous data. Now, data is collected. You have 100 data, and data collection plan is 100 data, and your data collection plan is 5 samples per shift. 5 samples per shift, and 5 samples per shift, and for
20.
let's say 5 days. And the company is operating in this manner, 4 shifts per day. Now, do you understand the data collection plan? There are 4, the company is operating on a 4 shift plan. Shift number 1, shift number 2, shift number 3, shift number 4. And every shift, you are taking 5 samples. In a day, totally, how many data you will get?
20.
20. And you do this for 5 days. So 100 data you are getting. So why I am explaining this is, I want you to understand that every time the data collector is going, he is collecting 5 samples. The 5 samples together is known as subgroup. Together is known as subgroup. So how many subgroups you have?
5 sub.
Totally how many subgroups?
20. Yeah.
20 subgroups you have. And inside each subgroup, how many samples you have taken?
5.
That is called the subgroup size. Whenever your subgroup size is less than 8 and your data type is continuous, you should go for a chart known as X bar R chart. Go for a control chart known as X bar R chart. Now R means range. What is that range? Subgroup range. R means subgroup range. Please note how many subgroup you have taken in every shift?
5.
Only 1 subgroup per shift, isn't it?
Yes, sir.
So that subgroup range is a representative of the shift variation. Am I right?
Yes, sir.
Throughout the shift, if you maintain consistent quality, range will be minimal. As the range increases, you can understand there is too much variation within the shift. Now, X bar. X bar is nothing but subgroup average. And the purpose of subgroup range is to determine the within shift variation. To determine the within shift variation. The purpose of subgroup average X bar is to determine the between shift variation. Now you will understand this once we plot the graph. See here, I go to stat. Can you see control chart?
Yeah.
Now you have variable chart for subgroup. Now you have variable chart for subgroup. Which chart I should choose now? X bar chart. Can one of you read out the description here?
Monitor the mean and the variation of your process when you have continuous data in subgroups. Works best within subgroup sizes or subgroup sizes of 8 or less.
This is the reason why we selected X bar R chart now. Now I go to this window. All observation are in one column. Now which is that column? Column number 1. I double click. What is your subgroup size? Minitab is asking. 5. Now X bar R chart options. In the option, there are certain tests you can perform. To understand the abnormality, there are certain tests recommended. Please tell me, do you have any kind of testing or observation you do within your house to understand the abnormality? within your house? Do you check something on a daily basis?
No, sir.
You don't test whether it is normal or abnormal. You don't test anything, right? Let's say in the kitchen, some gas leakage symbol is coming. Is it an abnormality?
Yes, sir.
Because you know what kind of smell will come from a kitchen every day. But one particular day, if it goes beyond a limit, then you will doubt, okay, gas cylinder, maybe some leakage. Isn't it? So likewise, it takes some understanding on the process to recommend the test. In a house, you can have certain number of tests as an abnormality. If your kids are not coming home after the school before 5 o'clock, that's an abnormality. Am I right or not? Normally, they come around 4:45. Up to 5, you can wait, no problem. But after 5 also, if they don't come, will you still keep quiet till 10 o'clock midnight? You will immediately call the school, isn't it? Same manner, you must have a process understanding and have some planned test for abnormality. There are recommendation, but all recommendation may not be applicable, for your house. Isn't it? If I don't use a gas cylinder at all, why should I test that, do that particular test? There is no gas cylinder. So you must have. But one general recommendation first I am going with, which is point appearing above 3 times standard deviation. You see here 3. What is the name of the point at the 3 standard deviation away from the center? Control limit.
Upper control limit. Control limit.
If any product is produced outside the control limit, that is clearly an abnormality. Please note. Because normal distribution is telling me that there is 99.73% chance for your items to fall under control limit. 99.73% is a good chance, isn't it? It's almost you are winning every time. That is the 99.73. If that itself is not happening, why don't you ask a question? So any observation seen outside the control limit is definitely an indication of a special cause. I am only selecting that, but as you gain knowledge, you can select all of these conditions, right? So now I am giving OK. Again, I am giving OK. Now Minitab has produced the control chart for me. You see here. Can you see the control chart? Now tell me, look at the R chart. Is that the range under control?
Except one value.
Which value?
That,
Which value?
8 to 1. Sir.
No, range is control.
598.
See, I am asking range. Range is under control, right?
Yes, sir. Range under control.
Range is fully under control. There is no
range is
problem
under
with the range.
Yes, sir. Yes, sir.
What does it mean? Tell me, what does it mean? What is range represents what? I
It's,
told you, I have typed it already.
Compare with
range,
the previous sample.
Subgroup range.
Within the
Subgroup range. Range means subgroup range. What is it actually representing?
Within the shift color.
Very good. Within shift variation. First range represents the variation in the first shift. Second range represents variation in the second shift. Suppose imagine Ravi Chandran is the shift manager for the first shift. And our Chandru is the shift manager for the second shift. Who is having a better control? Ravi Chandran or our Chandru?
Chandru.
only, sir.
Chandru seems to be very strict shift manager. He maintains paka control. Isn't it? That means the variation in the products produced during shift number 2 is minimal in the case of Chandru, but it is little more in the case of Ravi. But both of them are in the acceptable limit only. But still, I am able to differentiate. But I see a problem here, probably 17. Maybe 17, the shift manager is Netaji. Netaji, can you see your range here?
Yes, sir.
See, you actually you are maintaining a lower range. You need to understand. You are close to 0. Actually, Netaji is maintaining a very lower range, which is actually too good. But my question to Netaji is now, how can you be too good? Isn't it? See, completely maintaining a zero range is impossible. But he is close to that impossibility. That is a good thing actually. But I would like to learn from Netaji. Netaji, how are you able to achieve this? In the 17th shift, when you are the shift manager, I see, a perfect control, close to zero. Can you educate me? If you educate me, what will I do? I will internalize. I will make it a part of process so that our Ravichandran's average also will reduce, our Chandru's average also, everybody will, improve on. But overall, I don't see any problem. All of you, do you understand? And this person, maybe shift number 9 and shift number 14, the range is on the higher side. But still, all of them under control. I don't see any abnormality here because some variation always, we must admit, which is known as common cause variation, which is otherwise known as random variation, also known as natural variation, also known as normal variation. You should learn to live with it. You must learn to live with it. But looking at the other chart, since R chart is under control, you can read the X bar chart. If R chart is out of control, there is no point of reading X bar chart. Avoid reading X bar chart when R chart is out of control. One important guideline. And X bar chart, is it under control? X bar chart, tell me.
Sir, can you please repeat, sir? When it is?
When R chart is out of control, you should not read X bar chart because the range is used for plotting the control limit in the X bar chart. So R chart must be under control so that then only you can read the X bar chart. That's one important guideline. Now look at the X bar chart. Are you seeing all the points inside the control limit or is there any point outside the control limit?
Except 1/8 point is.
Except the 8th point. and the 8th shift, let me pick up one guy here. Maybe whom we can pick up. Saravanan. Saravanan is the shift manager. Saravanan, are you there? You are there. Okay. Yes. Saravanan, tell me why your subgroup average is out of control. You are the manager that time. What happened? See, subgroup average has to be under control, yes or no?